Hey everybody, so I recorded a very long multiple hour tutorial series on the vehicle template in Unreal, and I was intending this to be like a beginner entry into Unreal, learn how to use the program while also making a very simple arcade game. And then they updated the vehicle template to a newer version with 5.6 very recently. Problem is, I had already edited all of this footage. I had made this, multiple week course. I think it's about 4 hours worth of walkthroughs and learning everything about Unreal, but it's using the 5.5 MB4 vehicle template. So I am re-recording that for the course that I'm making, which I won't be able to release here. But instead of trashing the original one, I thought I'd just release it for free. I already have it. I'd rather not throw it away. And so I'm putting it on my YouTube channel, and I want to give you a couple notes about it because I still think it's worth using, and let me tell you why. First of all, the new vehicle template in 5.6 is not really that different from the one before that. So you should be able to follow along. Even if you decide to use the newer vehicle template, if you want a one-to-one, definitely use the 5.5 or earlier. But if you want to follow along the series with the newer vehicle template, there are a couple minor differences. In the new vehicle template in 5.6, we actually have fewer assets. We don't get all the level prototyping things, and the assets that are here are organized slightly differently. Same major stuff we'll be using inside the course, but you may see fewer folders, and that's fine. So don't be put off by that. Additionally, they renamed a few of the major blueprints. So for example, in vehicle template, the vehicle, this BP_P_vehicle, in the course, we'll be working with something called the advanced vehicle pawn, I think it's called. It's the same thing. It is the parent class for the off-road and the sports car. So anytime we're working with that in this course, it's the same thing. All that matters is you're working with the parent vehicle pawn. It does matter inside of the code. Whenever we do casting, we might cast to advanced vehicle pawn. In this case, you want to cast to whatever the name of this parent class is. So it'd be casting to BP_P_vehicle. Just know that if the name changes, you need to cast to that thing. Like you need the new name of the class. Another thing is the player controller. It might be named slightly differently. I think the old one was vehicle player controller that we use inside the course. In this newer one, it's called PC_vehicle. And related to that, they do the UI setup inside of the player controller, but you'll notice that you don't really see it in the newer vehicle template. In the newer 5.6 template, they do the UI setup inside of the P_vehicle. In other words, the parent vehicle instead of the player controller. So that'll be one difference to watch out for. So you'll want to cast to the parent vehicle instead of the player controller whenever it gets to that point in the course. Another thing is the UI layout. In the newer version, they put the layout on the right. But in the older one, in this course, in this older course that I'm releasing, it's on the left. It's the same thing. It's just where it's positioned on the screen. So, just be aware of that. And apart from that, there might be minor differences in, the organization of things and the static meshes that you see. Again, none of that matters. The course is just meant to set you up with understanding the vehicle blueprints that are here, building a couple mechanics like collectibles and a timer for elapsed time for like a time attack style thing and a win volume and all the basic stuff that we need to get started with this kind of template and get started with learning Unreal. It's meant to be very beginner level, a multiple hour walkthrough and building a couple things and getting an arcade game started. So sorry, this is a slightly older version. I always like to release the newer version of stuff, but I didn't want to trash it. And I figured maybe someone would still get some use out of seeing the vehicle template. Again, you can always just use the older one, the 5.5 or earlier template. It's basically the same. You can also use 5.6 if you feel a little bit more comfortable with, trying to figure out the slight differences, which I just walked through. But either way, I hope you get some kind of use out of it. So with that, I will go into the course. Again, it's entry level, basic Unreal walkthrough. It was originally built for a intro to Unreal class, but I hope you learned something and I hope it helps some of you out. For our project, we're going to want Unreal. So in order to use Unreal, we're going to need something called the Epic Games Launcher, which is kind of the hub that lets us use anything related to Unreal. One of those being opening the Unreal Editor, which is where we're going to create our game. So I already have this installed, but if you do not have this yet, then you're just going to open up Google. You're going to type in Epic Games Launcher. And you're going to use whatever the top link is. I'm sure it's fine. And at the very top, you're going to install on whatever your platform is. I'm on Windows, and that's usually what I recommend. Then it's going to give me a download. I have already downloaded this outside of the video and run through whatever steps you need to install it. Just follow the wizard. It'll be fine. Once you get through all of that, you'll probably have some kind of icon on your desktop to open up, but you can usually just go to a search bar on your operating system and type in Epic Games Launcher. You can do this. What I like to do if you're on Windows is right click and pin to start or pin to taskbar, which is down here. Just something so I can find it very quickly because I use it a lot. When you open it up, it's going to ask for a login. So this is the next step you have to do. Create your login. I have already created mine, so you can go through the process, whatever it takes to set this up. And once you're done with that, you will put in your email address, which you have hopefully already verified, and put in your password, which you have hopefully already created. So I'm going to do that now and sign in. And it may ask you for a verification, might send you a code on your phone or something like that. Kind of thing is always changing. So just do whatever it takes to securely log in, and then you'll get to this interface. Once you're here, I want to give you a brief rundown of what to expect and how to navigate to the Unreal Editor, which is where we're going to create our games. So you should know that the Epic Launcher does a lot of other things besides just creating games. And I'm already on the Unreal Engine tab. Probably the first time it's going to want to push its products on you. So you will probably be on the store. The big thing to know about the store on the left, these are your main navigation things. In the store, it's going to try to get you to buy things, or it may try to give you free games. Either way, do that on your own time. The buttons on the top will usually change depending on what tab you're on the left side. So you can browse games, you can look at news, but we don't have time for that. So let's go to our library. Our library is the list of games that you have either purchased or downloaded or claimed or whatever. Again, this is for entertainment. This is not for game creation. So we're not concerned with it, but basically your store is where you get it. Your library is where you pick the one you want to play. And the last and most important tab is Unreal Engine. Now on the Unreal Engine tab, you're going to see a lot of things. I want to show you what's most important. On the news tab right here, it's going to give you quick excerpts from things that were recently announced, or maybe an announcement of a new game engine version or something. It may let you know that there are some new sample projects you can download and experiment with. A lot of tech demos that get announced and a lot of other things. It's pretty cool, but we're not concerned about news for now. By the way, these tabs at the top, they could and probably will change over time, so don't worry too much if you don't see all this. I'll show you the important ones. Samples we will not use for the homework, but it's good to know about because if you want to learn about a new feature outside of the course, then you can download their sample projects and poke around and see how they set up their really cool parkour animations in their new sample project. You can just download it and poke around in their assets. It's actually really cool. A lot of different animation types and game types and industries and whatnot. So one caveat here is you typically need a pretty good machine to run this stuff. A lot of times these are tech demos, and if you're trying to run it on like an old laptop, it's just not going to open. So just know that you will need some pretty good hardware in order to go through their industry standard modern example projects. So Fab, you may hear this come up. I want to mention it here because Fab is their asset store where you can go and you can purchase assets, you can download assets. If you click the button, it'll open up in a separate tab, which you can see here. Don't worry too much about this. This would be if you were building your own independent game and you really wanted a really cool Gothic cathedral or a top-down character template or something. Like, yeah, that stuff is really cool, but for this course, we're more concerned that you can build the things you want to, not find very specific things that you may not be able to find. So the Fab store is very dangerous. I recommend that you stay away for now. So click on the library tab at the top. This is where we're going to spend most of our time. So when you open yours up, it's not going to look like mine. The reason being is I have multiple versions of the engine installed. Whatever machine you're on may already have something installed. Maybe it doesn't. Don't know. If you want to install a new version of the engine, you would click the plus button and you would do that, right? You can choose the version here. Couple quick things. You cannot install new versions of an engine on a lab computer. So this would only apply if you're on your personal machine. The other thing is, if you are going to install a new version of the engine, double and triple check the syllabus to make sure that you have the exact correct version. You will want to align with what the course is doing. So once you have your engine version, right, I would choose the one I want and click install. And I'm going to click X here because I don't want this newer one yet. You can actually set a current, like this is the preferred one you want to use, which I would align with the syllabus. So that's what this top section is for, is getting a specific version of the engine and installing it. So once you install, go through the whatever process it walks you through. It should be pretty straightforward. Underneath that, you're going to see your projects. Now for you, this is probably going to be empty because we have not created a project yet, which we will do in a second. But once you create a project, it will link it and have easy access for you to open up down here inside of your My Projects. And the last thing is your Fab library. So if you were to buy anything from the Fab store, it would show up down there. None of that is necessary for the course, but if you did pay some money for something, almost all this was free, which it is worth checking free assets every now and then. You can build up a little long-term library here. But anyways, this is stuff related to the Fab store and assets that you own. For now, jump back up here. This is the general rundown of the Epic launcher. You can see there's a lot of stuff to play around with here, but we really want to get into the engine so that we can start building our own games in Unreal. Okay, we're ready to go. Let's create a new project. So up in the top right, you're going to see this launch button. Take note what version of Unreal it's about to launch. So you can see it's set here. I can change a different one if I click the little drop down and choose one of the installed versions. So I'm going to use this one, but you should use whatever version the syllabus says. So once you do that, you're going to click launch, then you wait. And it's going to bring up this Unreal Project browser. Now, this will allow you to open previously created projects, allow you to create new template projects across various industries. You can click here and see some cool example stuff if you're interested in VR or AR or whatever. I'm going to click on Games, and inside of the Games tab, what we are looking for is the vehicle. So click on Vehicle, and this is going to give us a template project for creating a vehicle game. Once you've clicked that, you can read a little bit about it. The project details, we're going to keep it on Blueprint. This is visual scripting. C++ would involve coding and a lot of deep programming knowledge. We're not ready for that yet. Keep everything here except do check starter content. This will give us some extra assets to work with when we are building our mechanics, and it's pretty handy for prototyping. I'm not going to check ray tracing because it's pretty intensive, and I don't want to do that on my machine. I do recommend that you leave ray tracing off. We will not need it. Now, in order to create this vehicle project, we also need to specify a location. You can save this anywhere you know you will find it later, but I do not recommend saving this on a cloud drive because it'll try to access your files a lot and do some weird stuff while you're working. I'm going to save mine inside of my desktop, make a folder called projects and make a folder for Unreal, and just select this root folder. Don't click anything in there. And then I'm going to give my project a name. I'm going to call this AG Vehicle Game. And once you double check all your settings here, click Create. Okay, so I have my project created and now I'm ready to work. In this video, I recommend that you just watch and not worry about trying to follow along. I'm going to do a lot of file manipulation to show you how you can move your project files to different computers, how to manage it, how to open it in different ways. Don't really worry about following along because in the very next video, we're just going to start from here anyways. So just watch and try to retain all the information you can. So what I'm going to do is I'm going to close out. And I want to show you how you can reopen a project once you've closed it. So I'm going to open up my Epic launcher again. I'm going to go to Unreal Engine and Library. And then down here, you can see whatever you named your project, you should see it pop up in your My Projects down here. So I'm going to open this up because now it's a lot easier to find and open. It just saves it inside of my Epic launcher. And you can see it's open again, which is great. But let's say I've been working inside the labs and I'm ready to move my project files to some other location. So I'm going to close out. And once you close Unreal, I'm actually going to find my project over in my projects over here because I'm going to show you a really cool thing. If you right click and you say show in folder, it will bring up a browser window to show you exactly where your project is on your machine. Now, you don't have to do this. You can navigate if you remember where you saved it and you can find it that way. But it is very useful to know that you can just right click and find it on your computer so you know exactly where it is. So once I'm here, this is my project file. So if I ever wanted to open Unreal, if I were to double click this, you see it will just open up. You could do this without even using the Epic Launcher browser if you want. So it's just another way that you can open your project file. Just know that this file right here is what you would need to find and double click it to open. Now, let's say I'm ready to move to a different computer. You can see I have a lot of projects here, but don't worry about that. First thing I want to show you is how you can back up your project into a file that you could store somewhere and get later on. I guarantee you will have to do this this semester. You should be backing up your files in whatever method you can. This is one of many ways. So to do that, you're going to right click your project folder, everything in here, right? You're going to go back one and your whole project folder. I'm going to right click. You may not have this exact terminology, but essentially you want to either compress to or send to or create a zip file out of this folder. So I'm going to say compress to zip file. Now this is going to put everything inside of this file into a .zip file. And you can think of this as a package. Like imagine that you're trying to send something through the mail. You want to package it all up inside of a box and make sure that it can't be opened. And then that is our zip file. We don't want to double click to go inside of it. Like we could poke around and look inside, but this is very different from actually like working with our files. We don't want to do this. If we actually want to use any of the files inside of this package, we need to unpackage it. I'll show you that in a second. But for now, I'm going to close out of Epic Launcher and I'm going to delete my original project to simulate me being on a new machine because I'm going to show you what that'll look like. So goodbye project. Haven't really done much in that project yet, so it's fine. So this is my zip file that I've stored somewhere or I've put up onto Box and downloaded on a separate machine or put on a flash drive, whatever. I have my zip file and I want to pull the files out of this and use it to continue working on my project. Again, do not double click and go inside and navigate. We do not want to do that. We want to right click and unpackage the box. This would be like opening the package that you received in the mail. We're going to open it up. So right click, I'm going to say extract all and choose a location. It will default to wherever it currently is, and that is fine. So click extract. Now again, this might look slightly different depending on what operating system you're on or what, if you have 7-zip or some other program to handle this, might be a little bit different, but essentially we are unzipping our zip file. Once that's done, it's going to open a folder like this. I'm going to close this out just so you don't worry about that. If you look right next to our zip file though, it created a duplicate folder and put all of the files inside of it, unzipped it and put it into this folder. I'm going to delete my zip file. You can either delete it or not. It doesn't really matter. I'm just going to do it to clean things out. And now I have my folder with all the files that we pulled out of that zip file. Now you'll notice if I navigate in like this, navigate inside of here, we have this root folder that is kind of redundant. What I like to do is just go inside of this folder, select my inner root folder, press Control X to cut, go out to my parent folder out here and paste. Now, since it's the same name, it's just replacing everything. So now if I go inside, I don't have that inner one. It doesn't really matter. It'll still work if you were to open it up inside of Unreal, but it's just a little bit cleaner and more proper, I think. So now we have our project back on our computer. Now, one thing to know, if I were to open up the Epic Launcher, right here, it is still recognizing my project, but if you were on a new machine, it probably won't recognize your project because it's a totally different file location. So you will not see this. So I want to show you how you can load it up in case you're on a new machine. So, I mean, you could just go in and you could double click it and load it that way. But another way you could do it is if you go into the Epic Launcher and you click launch on the version you want. Inside of recent projects, you could just browse down at the bottom right here, and you could open up a new project. If it's not showing up in that little browser window over there, you can navigate to your project where you saved it. After you click the browse button, you want to navigate to the project file and then click open, and it will open it up. And the nice thing is, if it wasn't recognizing it before, now that we have created this file path to our project folder inside of that little window, now if you are on a new machine, it should actually recognize it. So I'm going to open it up now. That was all a lot of information to help you understand how project files are managed in Unreal and how you can move those to different locations, because you will probably have to do that at some point. And I wanted you to understand how the file management part of that worked, because it's not enough to just work here and we're never going to move anywhere. That's just not the real world. Knowing how to grab your project folder and get it onto a new machine will allow you to keep working on a single project more conveniently across different machines. Okay, so now that we're back inside of Unreal, at this point you should be trying to follow along and practice some of the things I'm mentioning in the video. First, we want to talk about our panel layout and how to navigate inside of Unreal. First things first, if you mess up anything, you lose your panels, whatever, just know that you can come up to Window, go down to Load Layout, and Default Editor Layout. If you click that button, everything will pop up at the same place that it started. So, if you're trying to customize windows and you lose your details panel and you're not sure where to find it or whatever, just go back to Windows, Load Layout, Default Editor Layout, and you'll get it back. You can also resize some windows. You can move them around if you really care about that, right? But sometimes they're a little bit hard to get back in the position you had them in originally, which will happen. So if it's easier to reset it, then you can always do that. But Otherwise, I'm going to keep mine fairly default because I think it works pretty well. In terms of navigation, we have our main game window right here. This is where you're going to spend most of your time. You have a few different ways to navigate here, and I want to show you 3 different navigation options, and then you can do whatever you're most comfortable with or what makes sense to you, and then I will give my recommendations of what I like to do. So the first option is our mouse movement. So if you click inside this game window and you do your left mouse button, you can kind of pan around and look, kind of like you're spinning around in a circle. You can move closer if you drag forward or drag back. And this is pretty useful. But if I want to look down, you will need your right mouse button. So you can kind of move around and look down, and this can get you to most places. If you were to press both mouse buttons, so left and right at the same time, you can go vertical. So you can see if you were to practice a little bit trying to move around. So let's say I'm trying to get closer to those blue posts over there. You could go over here and look around and kind of move and get really close to it. And that can take a really long time. So one other thing I want to show you before I move to the other methods, if you select something and you hit F, it'll zoom in really close. And that's kind of handy if you want to get to something very far away, like that wall over here. You can click it, click F. It actually made me farther away, but it focuses on the object when you click F, which is a very, very handy hotkey. The second navigation option that we have is the gamer mode, which is just if you hold down right mouse button and you use WASD on your keyboard, you can move around as if you were playing a first-person shooter, which is, what Unreal is very obsessed with. I guess it's third person now that they're, all in on Fortnite. But either way, if you hold down right mouse button, you do, they call it WASD control, so WASD. Move around as if you're playing a video game, which is pretty neat. While you are doing this, again, holding down right mouse button and WASD at the same time, you can also press Q and E to go up and down. So I actually like this method for moving around the world. You can see that it just feels natural, maybe because I play some games, but also I just like being able to move directly towards something. I look at it and I move in a forward direction and I get there. If this is too slow for you, while you're moving around with the right mouse button, you can scroll the scroll wheel and then it'll help you move faster, or you can scroll it down and you can move very slow, which I don't usually use, but if you're trying to get some very precise, like a very specific camera angle right there, maybe you could do it. Just know that that's an option for you. So that's the second mode of navigation. The third one is if you're used to things like Maya or Unity, you can actually just hold Alt and do your left mouse and click and orbit around, or you can hold Alt and do right mouse and zoom in and out, or you can Alt and middle mouse and pan. So if you really just want one control scheme, you're trying to simplify your life, you could also just use the Maya controls and do things that way. I will tell you, I tend to like the WASD method for moving around. And then when I get really close to something, then I will switch to the first method where you're using your mouse to get around. I usually like those first two, the second one for moving around quickly, and then the first one for just zooming in real close. Now, the second panel that I want to talk about that's very, very important is the outliner. And inside of the outliner, you can see a list view of everything inside of your level. So all these little posts here, if I want to know what those are, I can look over here, and it's called a bollard, I guess. And it's a cylinder inside of a folder, and you can expand that or close that. So I guess the other important thing to know about is that there are folders if you want to organize your objects, and I always recommend you organize your objects. You can create a new folder for navigating by pressing this button and then giving it a name. We're not really worried about that yet, but just know if you wanted to, you could. I'm going to collapse all of this down so you can see that top level, we have some assets that don't seem to have a visual inside of our level. So our players start, what is that? You're going to see some things that are related to gameplay, and then you're going to see some things that are related to visuals or collisions. You don't need to know all of it. Just know that you can poke around, and if you want to know more about one of these things. So cylinder 9, let's learn more about cylinder 9. You can double click it, and it's the same thing as zooming, right? So if I select it and then I press F, it's the same thing. You could either double click or you could press F to find that object very quickly, which is very handy. The last thing I want to talk about is your scene itself. Your scene itself is just a big container with objects inside of it. This will be important to understand later on, but you can collapse this whole thing. We could actually open up multiple levels if we wanted to do that. We don't. That's too complicated for now, but then you can expand it and just think about your scene or your map or your level as a giant empty box until you start putting things into it. So it's just a container. It's containers all the way down. Everything's a container for something else. And then we just want to make sure that we organize that and set it up properly for our game. Now let's talk about the details panel. So if I were to select an actor in my scene, so maybe this cube over here, select the object in the scene, you can select it in the outliner, whatever you like. If I scroll down here, we see this details panel. This panel will change depending on what I have selected. So if I select different things, our options and our information related to this object will change, right? Like I can select the sky sphere and we'll get different information versus selecting the cube. So I'm going to keep on this cube right here and you'll see the details panel down here. Things to know is that this is called an actor, and on my actor, I can attach components. So if I were to select this cube actor right here and let's say I wanted to add, you can think of a component as a block of functionality that can make this actor behave in different ways. So for example, I could attach a point light to my actor, and now as part of this cube, it now has a point light, which I don't really want, right? So I'm going to select that and delete it, my point light. There are so many other components you can add, and actually we can create our own custom components through code if we want. But for now, just know that it exists and what those are, because you're going to see an actor that has a lot of different things on it, and that's fine. It's just an actor with components attached to it. So that's what that's called. Up here, if I select my actor and I scroll down a little bit, all actors are an object that can exist inside of a world. So any actor in my scene over here should have a transform component. This just tells us what is the world location of this object, what is the rotation, and what is its scale. So you can see it's already been scaled a little bit. We can collapse that. You can see actor that we have selected. I have my ramp right here, but if I select the cube, you can see it has a static mesh associated with it. This is like a mesh file that we could import if we want. We can use the ones that are already existing inside of the Unreal Editor, but if you wanted to turn this cube into a, I don't know, a Goomba, you would import the Goomba mesh and, you know, it would look like a Goomba. So we can swap out the visual portion of any actor in our scene, which is very handy. We can also change the material if we want. I'm not going to do this right now. You could select something else if you want. Actually, I'd change my mind. I'm going to do it right now. Ooh, that's cool. You can change it to a new material. I'm going to undo it. But just to let you know, that's where you would find that, right? You can customize the visuals with your mesh or your material. And there's so much other stuff here, like collisions. We're not really getting that deep. You can put physics on this cube. I'm just going to collapse this all as I talk and ramble, just to show you there are so many parts of this one actor and details and components. It's too much, right? It's too much to look at. Don't worry about getting too deep into this. Just try to understand how things are organized. So if you want to mess with information on this object, that's where you do it inside the details panel. And then apart from that, it's just remembering where the thing is or what it's called. And speaking of which, if you don't remember, you can use the browser. So I can say, I think I'm looking for collision. So I'm going to type in collision and it's going to recognize my collision dropdown. But let's say that I wanted generate overlap. So let's say I couldn't remember what it was called, but I remember overlap was a keyword. So I'm going to type in overlap. You can see how it's going to isolate the stuff that I'm searching for, which is very handy. So make sure that you use a search bar if you're having trouble remembering all the stuff in Unreal, and you will have trouble remembering all the stuff inside of Unreal. It's just too much stuff. Use your filters, use your searching wisely. So far, we've talked about things that exist within the scene, but now I want to talk about assets. So down at the bottom left, you'll see this button called Content Drawer. You can press that button to open it up, but honestly, no one does that. Press Control and Space at the same time, and it'll pop it up real quick. See? Save yourself a lot of time. So Control and Space at the same time, or if you really want to, you can press the button. And this is all of our project assets for our project. Inside of here, you can see, so you're going to see some folders. If I want to navigate, like, what am I working with? Some things inside of our assets folder down here. So this is called our content browser. First, inside of this content folder, this is everything that we're working with inside of our project. Everything inside this engine folder, it can go real deep. I don't really recommend you go inside of here. It's stuff that the editor needs to run and all the basic code in order to do its job. So don't go into the engine folder. Instead, expand content. And this is all the assets that come available to us when we created our project. So our vehicle template, we're going to see vehicle related things, right? We could expand that right here. We could click around. We see an off-road car. That's kind of cool. Vehicle template, input, like what is all this stuff? You're not going to understand most of this, and you don't really need to. Like, that's the whole point of the template, is you can poke around and it's provided to you. But you should know where you can find these assets if you are curious, and we'll work with some of these in a little bit. So this is our basic content that comes with our project. I did want to show you one quick thing. When you are working inside of an asset, so let's say I go into my level prototyping and my materials. So I'm going to go into my MI solid blue over here just to show you something real quick. If I go into this and I were to, I don't know, let's change to a slightly different color blue. Maybe it's, more like that. Click OK. You see how we have an asterisk here? That means that we need to save it. We are working inside of an asset. So if I hit save, it needs to save our packages, and I'll close it out. It actually had to save our work inside the asset. So if I were to open this back up and then go, I don't know, like undo what I did, or maybe change it slightly, and I didn't save it, and bring this up, you're going to see an asterisk on this asset itself. When you are working on an asset, you have to save your progress. Otherwise, it's not going to take. It's not enough to just work inside of your scene and save it to your scene. If you're working on things inside of the content browser, you do need to save like whatever you have open. This needs to be saved as well. So I showed you how you can save inside there before, but let's say if you didn't want to go in there, you can actually select the asset that has an asterisk and press Control S to save, or you can right click and save. There are so many ways to save the assets, or you can hit save all. If you're just not sure, just like save everything I've been working on and it'll show you all the stuff. Just make sure that you actually do want to save any progress you do if you do it that way. So I just wanted to let you know, if you're working inside of an asset inside of your content browser, make sure you save it. Let me show you. If you right click on content, you go to show and explore. This is exactly where all of your content is going. Like if you look down here, you see level prototyping and starter content and track and all that. Apart from these top couple folders like these, everything else is perfectly aligned with what's inside of Unreal. So if you wanted to actually import some assets, you could do that, right? Like you would import them into the content browser. You probably want to do it that way. Like could add a new mesh or a new map or whatever, which we'll do in a little bit. The add button just creates a new asset down here, but the import button, you can bring in something from the outside, like a song you've been working on or sound or mesh or whatever. And then the save all button. So these three buttons, pretty important. Anyways, you can get rid of it if you come back to your scene and click around, or you can bring it up with Control Space. But that is the content browser, super important. This is how we manage all the assets we want to bring into our maps. Okay, the next thing I want to do is talk about actors, blueprints, and how we can manage those inside of our content browser and inside of our level. So the first thing to know is we can just add actors and different types of actors that already exist into our scene. This little button right here, this allows us to quickly add something into our level. So let's say that we want a light. Now, the important thing to understand is anything that goes into a level is an actor, but all of these things are a specialized kind of actor. So a light is a actor that also has the ability to be a point light. There are all sorts of actors you can add, like player starts, characters, pawns, and so forth. But these are all the provided ones that we have. So for example, to add a light, we would just go lights and point light. Move that around right here. See, we can light up our scene. I'm going to delete that. These are all the pre-built actors that are commonly used inside of our game. Now, in our games, we want to make our own kinds of actors, like enemies, power-ups, and all the other kinds of things that might go into a game. These are going to be special actors that we want to define and create inside of our assets so that we can create our specialized actors and put them in the world, kind of like how we're doing up here. So these are all the pre-built ones, but let's say if I want to make a specialized kind of one, so I'm going to go inside of the vehicle template, and let's say blueprints. Anything related to blueprints is functionality. So we have a game mode, different game modes, UI, vehicle player controller, vehicle advanced pawn. I'm gonna even go into the sports car. So if it's blue, it's a kind of blueprint. And so if I find a blueprint of a certain kind of actor and I double click and I open it up, you can see a lot of components on it. You can see a lot of, there's like variables here, there's functions and other things. So we can define this actor to be however we want. And inside of our blueprint editor, you can see this event graph. So this is where we would put any logic. You can see there's none here right now. Don't worry about the construction script. This is a very specialized thing. The main thing I want to show you is the viewport. Now I can move around just like I do inside of my scene. You can see that it looks like a car, and you can see that there's a camera related to it. You can see a camera arm, actually multiple cameras for a driver's view and vehicle movement and a lot of other stuff. So my point here is that if we want to create a specialized kind of actor to go inside of our game world to perform functionality, we can create that as an asset and define it. And then just to show you one more, I'm going to drag this into the world. We can then add it into the world as an instance of our blueprint that we created. So a blueprint is a definition of something, and then an instance is we make a copy and put it into the world. The way to think about this is you have a cookie cutter, like a metal shape of a type of cookie, like a moon, and then our cookie cutter can stamp out some cookies, and those are the actual cookies, but we're using the cookie cutter as a template to make lots of different kinds of cookies. In this analogy, our blueprint is the cookie cutter, and we can create as many cookie cars as we want. And these are all going to get their functionality based off this blueprint. This will be really important to understand once we get into programming, but for now, all you need to understand is that this is our blueprint, this is our template, and these are instances of that blueprint. So our blueprint is the asset, and these are just objects that are using that asset inside the world. I'm going to select each one of these and delete them. So you shouldn't have those, right? I was using it for example, but make sure you remove those. And I want to show you one more thing related to actors. If I go into my scene and I collapse everything, when I hit the play button, you're going to see that there are additional actors that get spawned when I press play. So press it. Let me come back over here again. You see these yellow ones? These were spawned at runtime. So you'll see things like a network manager, a game session, a camera manager, player, state, sports car. All this stuff is getting spawned automatically and not until we hit the play button. So all of those are instances of blueprints that are created somewhere as well. Now, you don't need to understand all this. You just need to know that there are objects, so actors, that are created when I hit the play button that are based off blueprints inside of our assets somewhere in our project folder. So that's the organization of how we spawn things and how we organize our functionality into assets and how we put those assets into the world. Now, let's actually start customizing our map. I'm inside the vehicle example map because that's what opens up by default, but I don't really want to change this map because maybe I want to come back to it and see how they did something, and I don't want to accidentally delete out my track or whatever. So I'm going to make a new map called Sandbox that I'm going to customize and alter and manipulate and keep this vehicle example map still available as a separate map if I ever want to come back to it. Inside of my vehicle example map, I'm going to press File and Save Current Level As because I want to make a copy of the current state of my vehicle example map into something new. What I like to do inside of my content browser right here is right click and say new folder called _game. And the reason that I like to do this is because I want all of my assets grouped under one thing, and then all these other assets can be floating out here. This is not the only way to do things. This is just how I prefer to set up my project. So I'm going to go inside of _game, make another folder. So right click, new folder, call it maps. With that folder selected, I'm going to make a new map. This is our save level as, and we'll call it Sandbox. Traditionally, in game development, a sandbox is a little test room that you use for testing mechanics and trying things out before you try to build a larger level out of it. It's kind of like a playground. We have the starting point of one already. I'm going to hit Control S to save. I'm currently in my sandbox, but I want to show you something. If I close out of Unreal and I go back in, let's open it back up. You'll notice that it opened up back into vehicle example map. It opened my project, but then decided to try and guess at what map I wanted to open up. It's not the last one I had open. It's whatever is set as the default map. I don't want this to be set as the default map anymore. I want my new sandbox because that's what I'm going to be working in. And I'm going to get confused if I do some work in sandbox and then it opens back up into here and I'm like, where did my work go? This is a different map. So to set a different default map, we're going to go to Edit, Project Settings, and you're looking for something called Maps and Modes. So if you click that, you're going to see two things here under default maps. There is Editor Startup Map. So this is the one that will open up when we open up Unreal. And I do want to type in Sandbox. There you go. And it should pop up. I want my sandbox to open up anytime we open Unreal. Our game default map is whenever we build out our game as a separate executable and run it, what do we want the first map to open up? So what are the players playing first? Usually it's a main menu map or something like that. For now, I'm just going to make that my sandbox as well. So I put sandbox for both of these. If I close this out, you can test it out. I'm not even going to open my sandbox here. I'm just going to close Unreal and reopen. And now it opens up my sandbox map. So now if I do some work inside of this map, not only am I separate from my other vehicle example games, so I can always jump back to it if I want, I can customize this as much as I want and I won't mess anything up. I'm in a duplicate map and I can just experiment. And it's also the default map. So if I close out Unreal, it'll open up right back where I left off. Next, let's talk about all the different assets that come with our vehicle template that we can work with as we begin to experiment. So we have our underscore game folder. This is the one we created. All it has is our map for now. We have our level prototyping. This is where we have some provided meshes and materials and textures. This is useful for just making little blocks of things and little ramps and kind of like little jungle gym sort of setup. So we can use some grid materials here. We could have a flat blue that we can apply on some things and a lot of meshes for ramps and cylinders and whatnot. So pretty useful. We also have our starter content. This is what we imported when we originally created our project, and that has some architectural pieces, some audio files, particles, props, and a couple other things that can be really useful for quickly testing visuals or making some prototype assets and mechanics and just a lot of stuff here that is kind of nice. We have our track, which is our, this is our material for our track right here. So, you know, we could change that color if we want. And this is our checker for our track edge. So whenever this is, you know, outlining and doing this little alternating color piece right here, so we could always alter that. And this is our static mesh that we are using as part of our spline tool setup to make the track. So I'm not really going to mess with this too much right now, but that's what's in this folder. We have our vehicles, which these are all the assets and art and physical collisions and things like that that are related to the vehicles that we have available. So things related to the sports car in here. You can see it can be a fairly complicated setup. We have our off-road car, you know, materials, again, very complicated. But our vehicles folder is our art and collisions and meshes related to our vehicles. Finally, inside of our vehicle template folder, this is where we're going to spend most of our time if we are working with the provided assets in the vehicle template. So if you look down here, we have our blueprints folder. So we have our game modes. We have a vehicle advanced pawn. This root one, I think, is one that you can use to customize a vehicle later if you don't want to use the provided ones, but we're not really going to mess with that for now. We have our player controller, which is what helps control the car, and our UI. If I were to open this up, you can see that we can build a widget that gets displayed on our screen whenever we hit the play button. So this is our UI down here, and we can add some functionality to, like, you know, match the speed or talk about which gear and so forth. Which is pretty useful, but we're not going to mess too much with it for now. We don't want to break anything. If we go into the subfolders, these are the blueprints related to there's an off-road car that we could mess around with if we want. Some data related to how it steers and turns and moves. And there's also the sports car, which is the default one we're using right now. And same thing, like max speed as a curve, and then some wheel data, which is pretty handy. So that's all the blueprint stuff. Also, I want to show you there's the input. So how do we know what buttons to press inside of our little input folder? There are two things you need to know. There is it's called a input mapping context, which is our map of all the different actions we want to use. So open this up, you can see there's a throttle, there's a brake, a handbrake. Check this out. There's a toggle camera. If you press tab, you can expand that and see, oh, wow, we can toggle our camera. That's pretty cool. You can reset. So this will help flip your car if it ever gets stuck. So you can do that with backspace and then steering, right? So these are all the button presses that we have available to us and the actions that will be performed when these buttons are pressed. We could change these. We could add some. We could change the button presses. Do not change anything here. I just wanted to show you where to find it and where it's set up. You want to know where those actions came from in the subfolder. These are all the actions. Like, we could create a new action and hook it into our map, but we take all these actions, we put them into our map, and then we assign key presses to them. That's how we can add new button presses inside of our game. And the last thing is our maps. There's a example vehicle map, which is the one we used to be in, and an off-road example map. Don't worry about it. That's just what's provided inside the folder. The last thing I want to mention is this could change over time. The vehicle template could be updated and these folders might look different, but I just want to give you a view on how you can look through the provided assets. So blueprints are typically functionality. Input is related to the buttons that you're pressing and what happens in response. And our maps are the scene files. And then apart from that, you'll see some art assets that are floating around. Okay, so the next thing we want to mess with is the player camera. Right now, it's pretty far behind the car, and this is fine. Like, this is pretty standard in racing games. But I just want to show you how you can start to manipulate this stuff and create something a little bit more customized. So for me, I think in my racing game, I want to have a more overhead camera. Where exactly you end up positioning the camera is kind of up to you. Just use your best judgment. Don't do anything too wild though, and I'll show you where to find this stuff. So I'm going to be inside of my vehicle template, my blueprints, and my sports car, because this is the car that I'm using, and double click that. And if you go over to the viewport tab, it defaults in the event graph, go over to the viewport, then you will see a lot of these components that are added on the side. One thing I want to show you is if you lose the viewport tab, for whatever reason you close it, you can always get it back if you go to window and go down to viewport. All right, so hopefully that didn't happen to you, but if it did, that's how you fix it. You can see where the cameras are positioned behind the car. So for me, let's say I want to position it way up here. I want it to be kind of like an overhead looking down. And the way that you could do that is something called the back spring arm. So this back camera is our default camera view. There's also another one we can toggle between if we want an inside the car, but for my behind the car one, that's our back camera. This spring arm is what positions the camera behind the car. So if I want this camera to be up here and maybe, somewhere up in this location, I want to change the back spring arm, not reposition the camera itself. So I'm gonna go to my back spring arm. I can look at the down here in camera settings. Let me minimize those. In my camera settings, you can see the target arm length and you can see the socket offset. My length is really like how far I want it to be behind the car. And then my offset is in what direction do I want it to be behind. You can see it kind of adjusts both to some degree. And you can play around with this, but the settings that I found is 1500 for the target arm length, because I want it to be pretty far back. And then for the socket offset, I'm going to change this to something like 1200. So it's pretty far out there. And if I were to compile and save this, I want you to think about what this is doing. If I hit play, watch what happens. Whoa, we're way up here and our camera's way down there. Well, that's because inside of our camera is still angled forward, so you can still position this as well. Let me go to my camera and I'm gonna hit E for rotation. And I'm going to angle this down just a little bit. I think about -30 is good for me. So we'll be doing kind of like an isometric style view, not fully, but pretty far away. Compile, save, hit play. Okay, and I kind of like this angle right here because it lets me see far ahead. In a racing game, it's important to see where you're going, right? But it also helps disconnect me from being right behind the car so I can get a good feel and view of everything that's around me. So this is the style that I want. For you, you can actually customize this. Just don't go too crazy. Like don't go like way out here, or don't angle it so far down that we can't see what's in front of the car. As long as we can reasonably see in front of the car, like you could also have it right behind if you want, then you can customize these settings. I wouldn't do anything beyond what we touched. So our target arm length, our socket offset, and our camera angle. I think as long as you're messing around with those, you should be fine. But again, if you cannot see in front of the car, you're tilting it down too much. So you should have the car either halfway or mostly in the back, and then just decide how far you want to, be behind the car like that. So play around with those settings and try to get your camera in a place that is comfortable for you for your game type. Okay, now that we have our camera where it feels pretty good, we want to adjust the car to move just a little bit closer to what's comfortable. This feels a little bit stiff to me, which is probably accurate to a real car. But I think I want it to feel slightly more arcadey than this for the type of game that I want to make. So let me show you where you can manipulate that. And the short answer is in a lot of different places. This is using a fairly complex vehicle setup, meaning that you can find a whole lot of settings inside the blueprint. You can also find more in some of these other assets that are related. So we are only going to touch 3 different things, and beyond that, like there are ways to experiment, but you don't want to do too much because these are based on like real car settings. So let me show you. If I open up my sports car _ pawn and I go to vehicle movement, just look how many settings you can manipulate. Like I can expand like engine setup. Oh, there's curves here and max torque and engine rev up MOI and so many other things. Differential, like you're not going to know what a lot of this stuff is unless you're just really into cars. And that's fine. You don't need to understand everything. If you did want to set this up accurate to a real car, you could, which is pretty cool. But instead, I just want to show you a few places where you can start to play around and get the car feeling a little bit closer to a more action-oriented setup rather than a realistic one. So what I'm going to recommend is the first thing you can mess with is the max torque. Right now it's at 750. I did a little bit of testing before the video, and I actually like the feel of 1000. This is actually going to make the car quite a bit faster. So if I compile save, you'll see, hit play. It's going to go up to its max speed pretty quickly. We're already at 135 or 140. And it feels really fast paced, which I do like, but you'll notice that the faster we go, the harder it is to turn. And maybe I don't like that. I want to move fast and react fast as well. So I'm gonna hit escape. And the other thing we can do if we want to mess with that, you might think that everything is inside the vehicle movement component, like there's already so much here. Well, no, there's even more stuff. If I close that out and I go to the sports car wheels front, and that's not even the back wheels, we're just gonna mess with the front wheels for now. Open it up and you're gonna see even more settings. Again, there's so many ways to customize this. I don't wanna feel overwhelmed. I just want to show you a couple settings to start tweaking. So I'm resizing my window here. I want to show you two settings here that you can mess with to create a slightly different feel. I think I want to be able to steer a little bit more quickly side to side when I'm going very fast. So one setting you can mess with is called the friction force multiplier. Basically, the higher you put this, the more it's going to feel slidey and kind of like a go-kart, like if you're used to Mario Kart. I don't recommend pushing this up too much. I'm going to put mine up to 4. And even if you put it up to 5, it's going to start sliding around, but I'm just going to bump this up from 3 to 4. And just with this one change, you're going to see, so if I hit play, it's going to turn quite a bit more quickly when I start, right? Like not all the way, but it's just enough that it feels right, because I still want to be able to slow down sometimes, like I'm letting off my gas a little bit when I steer, or I can brake and make a sharp turn like that. I think this is the right balance. I wouldn't go above 5 or it's going to start feeling really weird, but I think anything between 3 to 5 is going to be pretty good. So I'm going to keep mine at 4. And the last thing I want to show you is you'll notice, well, one, I'm hitting compile save. I probably should have called that out earlier. This is an asset, so I need to actually compile and save so that the engine will update its logic. You'll notice that when I hit play, my wheels themselves are not really turning a whole lot. Like they kind of are, but what if I want to be able to turn even more quickly, right? Like especially when I'm moving slow. One more setting you can mess with is called the max steer angle right here. It's set to 40. You can actually push this up more. So I'm gonna put this, let's say 60. And so we're gonna see our wheels, just even visually, you'll be able to see this, but you'll be able to feel it as well. Hit play. You see my wheels I can really turn around really quickly. Very maneuverable at low speeds. But if I were to go fast, it still does dampen my turning, which is kind of nice. Like I like that middle ground right here. And I like the ability that if I'm going slow, I can really try to get onto a ramp for an obstacle course or something like that. I think these 3 settings that we messed with are plenty to get started. That was our max torque inside of our blueprint and our vehicle component. Our vehicle component, which is getting hidden because we're not scrolling down right here, but it's right there. If you click this, our max torque we messed with. Again, lots and lots of other stuff. And inside of our wheels front, we messed with our friction force multiplier. We bumped up to 4 and our max steer angle. Again, feel free to play around with these and make it feel a little bit closer to how you want. But I like these settings, so that's what I'm going to use for my version of the project. Another thing I wanted to show you is how you can customize the look of the vehicle that you're using. So if you remember, our vehicle template has all of our functionality and our vehicles folder has all of our art materials. So what I can do is, since I'm using the sports car, I'm gonna hop down into that subfolder under vehicles, sports car, and you'll see this folder, materials. Inside of here, I want to point out that typically in Unreal, a material is kind of like a very large, complex asset that shows all the instructions for how to render out your material and how to make the surface look a certain way. I don't want to worry about that. I just want to show you how to change the color real quick. So we can make something called a material instance from a base material. And then a material instance is kind of like a more optimized, protected version of that material. So for example, if I find my M underscores my material, if I find a MI underscore name of the sports car body, this is going to be the main parts of our car. So material instance is built off of a material. So this is very complex. This is my material, but my material instance looks like this. You can see there's only a couple settings here, and one thing you can do is under base color, I'm going to go down to, well, I had that checked. It should be unchecked by default. You can check it to override a particular parameter here. So you can put a fall off or a, energy conservation, whatever. This color right here, if you check this, so metal parts tint, I take that and I'm gonna pull it all the way and make it like fire red. I think that would be pretty cool. Honestly, you can make this whatever color you want, but if you click OK and then you hit save, you jump back in, hit play, see, you can change the color of your vehicle. Now, I actually recommend that you customize your vehicle to look exactly how you want. However, I'm going to turn mine back to gray because I want mine to be pretty standardized and not distracting from all the different sorts of colors that you all will be making. So I'm going to uncheck mine to show you that we can then revert back to the original gray color, right? This is just saying I want to override it, or I don't want to override it, just use the basic gray. So I'm going to hit save and back out. And so I'm back to the very boring gray, very functional, but not super exciting. But if you want to customize your car, I actually highly recommend you do that. And you can make it any color you want. And later on, when you get into the environment art portion, then you can try to figure out how to make environment colors that contrast with the color of your car. But anyways, I'm gonna put mine at gray, but any of you who want to change it to a different color, that's how you would do it. And feel free to change it to whatever color you like best. Okay, so now let's start to build a little obstacle course for our car. And I want to show you how we can begin manipulating actors inside of our scene to create some little area that our car can navigate. So we have our big track. We're not really going to mess with that because it can get kind of complicated, and we'll do more of that later on. And so I'm going to come over here to my ramps and my bumps and my cubes, and there's so much we can do with just this. So first of all, if I want to move an object around, if I want to move this bump, you can select the bump. If you press WER, it'll rotate between your manipulators, very similar to Maya or other such programs. If I hit W, you see I can move it around. That's great. If you press E, you can rotate it. Also great. Put that there and move it. Doesn't really matter. R will scale. You can either scale uniformly or you can scale along one axis if you want to make it big. That's fine. You make like a line like that. And go that axis, I'm gonna go that axis, and then just a little bit more, like a big bump. Maybe that would be useful for testing. And this is pretty good. So this is how you can just move things around, rotate them around, and scale them around. So already you could start to manipulate these objects. But one thing you're going to want is more objects. So to duplicate an object, if you select, let's say your ramp, if you press W to go to your movement manipulator and you hold Alt while you drag, you'll drag out a duplicate from the original, right? So you can drag that out. And then I'm gonna press R and let's make a slightly steeper ramp. And we also want our cube. So I'm gonna select my cube. Again, hold Alt, drag it out. By default, we have snapping turned on. So you can see that up here. If you want to turn off snapping, which you should never, ever do, you can press that button and see, no longer snapping. That's bad. So I'm gonna undo, turn it back on. If you want to increase the increments or change the increments for where the snapping is, you could. But if you do this too much, you're gonna have a hard time lining things up. So I'm not gonna mess with it. If you just want like really big blocks of snapping, you can always change this and do it that way. But for now, I'm just gonna work with smaller increments, but that's where you can change that if you want. So I'm gonna line it up. I'm going to press R for scale and then scale it up to mostly match. It doesn't have to be perfect, and that's fine. Let's say I wanna make it longer, and then we're gonna do another ramp for here. So hold Alt, drag it out. And for this one, I kind of want to test how my car jumps off of a ledge. Like, can we get a lot of height? Does it create problems? I don't know. Maybe, maybe not. So we can do that. And if we want it to actually seem, realistic, we could scale that out a little bit more too. Perfect. Big ramp. And that's how you can start to manipulate objects. Control Z to undo. I've been doing that here and there. I probably should have called that out. Past that, once you build some stuff, you want to test it. So hit play. Let's test our little, forgot about that one. Tricky. Go over here and let's see if we can get some air. Oh, not enough. Okay, not enough to flip it. But you can, do some turns up here. You can scale it out. You could rotate it. You can do a whole lot of stuff. All I really want you to do at this point is make a little obstacle course. Like make different kinds of ramps with different slopes, different angles, make a little pathway, try to make something where you can test if you can flip the car, right? Like maybe the bumps, how big of a bump can you go on? What happens? Can you get caught on a bump? Really just make a little playground for your car to drive around and see what feels about right. And actually you can find even more inside of our starter content. You might be able to find some like architectural things, right? You can scale these out. You can play with a lot of stuff. Just use what's available and make some interesting little obstacle courses. Like, can my car fit through a door? That would be cool. How big of a door could I fit through? Oh no! Oh wow, that was nail biting. All right, so experiment with this, build an obstacle course, and practice manipulating objects. All right, we have our car, we've tweaked our camera, we have an obstacle course, but it still doesn't feel like a game. So as a game designer, you should be thinking, well, how can I turn this essentially a toy or a sandbox into something that has a full game loop? One place to start is considering a win condition. So win conditions that are common inside of vehicle types of games might be reach the end of the level, so you get to the end of the track without your car blowing up and you win. You beat the level. Congratulations. The other common win condition that you'll see in vehicle type games might be like a time-based one, where you have this counter and you try to get to the end of the level as quickly as possible. Mario Kart, games like that. And then you can compare how well you did on this run versus the previous one. You try to get the lowest time possible. I would say the first of those, like just reaching the end of the map, is going to be the easiest to implement. And you can also use that in a lot of other game types. So we're going to use that as our win condition. We're just going to say if you get through the level to the end, then you win. And that'll be our vehicle game. The other thing I think might be useful is some kind of collectible or some kind of little option that we can choose to get for additional challenge. As we're making a very difficult turn, we could try to pick up some collectibles along the way and get to the end of the map. So this is pretty common in games. Collect all the coins, collect the special red coins, collect the Donkey Kong letters, whatever it is. The collectibles give you a chance to take some risk for additional reward, and I think it's a fairly easy mechanic to implement, so we'll plan to have collectibles as well, so we can have a little bit of spice inside of our level and round out our vehicle game. So we're not going to build those things in this video. We're the designer. We can possibly prototype some things, or we can make the request from programming department to build these things for us. And for now, I put in the requests and I'm just going to continue tweaking my vehicle, and we'll worry about that in programming week. For now, just tweak the feel, put more time into your obstacle course and just make the car and camera feel as good as you can and to your own personal tastes. One more thing that we need to do is create some materials that we can put on different mechanics inside of our level. Our programmers are going to set up our mechanics, but we want to build some simple materials so we can quickly change our visuals while we're testing and experimenting. So what we're going to do is we're going to create a material and set it up so that we can very quickly create something called material instances off of that material and make a lot of color variations. So I want to do that now so that once we have our mechanics, we can color code them very quickly without all the setup. So to do this, I'm going to go to my _game folder. I'm going to create a new folder called materials. And inside of my materials folder, I'm going to create a material, which is going to have all my information. And then it'll allow us to create lots of material instances off of that for the variation. So first, right click, find material. For me, it's right here. And we'll use the prefix convention, which is m_prototype material. Right when I create it, it gives us an asterisk to let us know that we need to save it. So make sure it's selected and press Control S. And we can open this up. We're going to see a pretty big node here with a lot of inputs. Don't worry too much about it. We're only going to use a couple of these. And honestly, I'm going to move through this section pretty quick because I mainly just want to show you how to set it up. You don't need to understand all of the material editor. It's way too complicated. So our approach is that we are going to identify a few things that we want to expose for editing when we create different material instances. For example, we may want to choose a color on a material instance. We may want to choose how metallic it is or how rough it is. For me, I'm going to expose the color, the metallic, the roughness, which is kind of like how shiny and reflective it is, and then how strong the emissive will be. So let's set that up. Our base color is going to be the main color. To be able to choose a red, green, blue value, we want a vector. And specifically, if we want the designer to be able to choose a new color to expose it, we want something called a parameter. So in other words, we want a vector parameter. So parameter just means expose it so that it can be changed. For a vector parameter, I can right click, I can type in vector and space parameter, right? So we got our vector parameter. We can call this base color. The designer should be able to select this and then use the RGB to create a new color. So what we're going to do with this is just connect it straight into base color. Pretty simple. But we're also going to set up the default on this because I don't like black being the default. I want it to be some kind of gray. So down here under default value, you can click the color and you can color pick it if you want. But I'm going to click on the red, green, blue values and say 0.15, tab 0.15, tab 0.15. So it's going to be kind of a lighter gray. I'm going to select OK. All right, so this is going to be our base color. We also mentioned that we want to expose the metallic and the roughness. You can hover over if you want to see a description of what this is, but basically how metallic is this material. So if we want a number that's exposed, right? Exposed being parameter, we want a scalar parameter. Scalar just meaning a number. So we could right click and type in scalar parameter and you'll see it pop up there. But I want to show you if you hold down S and click, that's a shortcut. It'll create it, but it'll also put a lot of S's in there. So let's change that to metallic. All right, so this number will be exposed when we create a material instance. That's why we're using a parameter. So I'm going to plug this into metallic. We want the default to be 0. That's fine. I'm going to also go over here under my details panel. I'm going to make the max 1. Because anything over 1 is kind of redundant. Since 1 is fully metallic, it doesn't make sense to go above 1. So just know that we can actually clamp that if we want to set a max value, which is pretty cool. I'm going to hold S again and click, or you can search and find it either way. This one is roughness. And we want our default value on this one to be 1. Because 1 is going to be a matte color, not reflective, and 0 is going to be fully reflective, kind of like a chrome or a mirror. So let's connect this into roughness. All right, so we got these two. We can also set the slider max to 1 for this as well. And the last one's going to be a little bit tricky. Technically, we want our base color, and we want to plug that into our emissive. This is how much it glows, or rather the color in which it glows. So I'm going to make it glow, but I don't really want it to glow by default. So it's actually trying to put in a 1 value in here. Instead, I want to take this and multiply it by a number, and then we're going to expose that number. So drag off this top nodes, this is our combined color, and type multiply. So we're going to multiply this color by a number and then put the result into there. So I'm going to drag off of this and plug it into emissive. And you can see by default, it's saying 1. I actually want 0 to be the default, but instead of using a number here, I'm going to create a new number. So hold S and click, change the name to emissive strength. This will be useful if we have power-ups or pickups or other things that we really want to glow and look really cool. So I'm going to have the option to do that. So default value 0, I actually do like that. I'm going to plug that in. And you see it's not really glowing at all by default. And I do like that, but if I wanted it to glow, I could put in 5 and it would start glowing, which is great. And put that back to 0. Okay, so I think this is good for a setup. Again, material editing can get real complicated. We're just going to do this and then make material instances off of it so that we can customize some different materials very quickly. So save this, minimize or exit out or whatever. And you see I have my material, but these are just our instructions. We really want to make material instances off of our instructions, right? This is our cookie cutter, and then we want to make cookies out of it, right? So let's say our bumps over here. Let's say we want some special color for our bumps. We can go over here and click on our material, right click and say create material instance. That's going to make a material instance off of this material. I'm going to change the name to mi_bumper. Press Control S to save. And so now if we double click our material instance, you see we don't get all the instructions, we just get the exposed values, which is exactly what I want. So let's say on my bumper, I want to change the base color. I don't want to do anything with the emissive strength or roughness or metallic yet, but for my base color, I'm going to click the color. I'm going to choose, I don't know, let's make it like teal or something. I guess we already have a teal, so let's make it more cyan, I guess. Make it a little bit brighter so we can see it. Okay, and we'll save it. And all I had to do is do the check mark to say, I don't want to use the default. I want something new. And then we can change that to something new and save. And then you can see how quickly we just created a new material that we can put onto something. So I'm going to drag these onto here, onto my bumpers like that. You can also select the object and then, find it in the browser over here. Or you can select an object over here. You can right click, copy the material that I want, and then go to material in the new one and paste. There are a lot of different ways you can assign materials. There's even more than this, but I'm just going to get my material on all of my bumpers. Okay, that's pretty good. And just to show you, if I did want this to be emissive, which, you know, I don't think I want yet, but if I did want, if I put it at 1 like that, and put this on a separate monitor, see how they're glowing a whole lot? Well, what if I put this on like 5? Save. Like, that's pretty cool. Let's bump this up a lot. Let's say 15, right? And you can only do this so much before it looks kind of crazy, but this is pretty cool if you're trying to build mechanics and you really want them to pop out and you know, you're just prototyping and testing things. You're not really doing a full art pass. You can very quickly create some test material instances if you set it up like we did and apply those to your new mechanics without really causing too much trouble. So let's undo my missive. I'm going to uncheck, save, and close it out. And there we go. We could actually start to color code parts of our obstacle course if we want. We can make our ramps a certain color. I don't necessarily want to do that, but you will need to show that you have your material and material instances set up, at least just one. For a sandbox, as long as you are using some kind of color that you made and it's very noticeable that your instructor can see it, then you should be good to go. So eventually, whenever you show off your map, you should be able to see the colors in the scene as we're going through, right? So we can tell that you actually have this set up. It's going to be important because later on when we are programming the mechanics, you actually will need to quickly use this to create new material instances, which is why we're setting it up now. And this is very common for a game designer to do too. The game designer will set up a lot of test assets and play around, so totally viable to set up a prototyping material that we can throw on assets. And then our programmers can take our test materials and use it for making sure that our mechanics are visualized inside the scene. So we'll look at that in a future week. Back up your assignment. I'm going to recommend once a week at the bare minimum. Find your project folder. I know for sure this is mine, this AG vehicle game. Right click, compress to zip file. Now maybe this is worded slightly differently on your computer, but as long as you make a zip file out of your project, you're fine. This may take a second. I should also mention to make sure that you have Unreal closed if you're getting any errors when you're trying to do that. Once you're done, it'll create this zip file down here. You can rename it. I'll say week 8 or whatever your week is. The name doesn't really matter as long as you know where to find it and you label it appropriately. Then you can take this and you can put it anywhere you want. I'm going to cut it, put it on my desktop inside of a folder called temp. So I can always come back to it if I want. So do not continue until you have a backup of your project saved away inside of a zip file. By the end of this week, we're going to have a boost pad, collectibles, a stopwatch, and a wind volume you can launch across. Your car will park, and everything will display accurately in your UI. First, open up your project, and when you're ready, we're going to do a practice run on creating some kind of actor that just has some generic tests in it, which we'll use to experiment with learning about blueprints and coding. So I'm going to press Control Space to bring up my content browser right here, create a new folder inside of my _game folder. So right click, new folder. We'll call this Blueprints. And everything that has gameplay logic in it, we're going to put inside this folder. So let's make a practice one. To create a new blueprint actor in the world that can do things in the world, we're going to right click inside this new folder we made, go to Blueprint Class. So we're making a new blueprint class. We have a lot of options here. The most common one is actor because we're not making new kinds of cars or new game modes or whatever. And an actor just means anything that can exist inside the world. It's pretty generic. The naming convention for any kind of blueprint is to start off with BP _ and then try to describe what the thing is. So in this case, it'll be test actor. We're just using it for learning. Now, once you create it, you're going to see this asterisk. That means that it needs to be saved. Otherwise, if we get a crash right now, it's not going to remember that we created a new asset. So I like to just select it and press Control S to save it, or you can right click and save it, this other way. Either way, we have a new blueprint actor created. Now it'll only exist inside of our assets. So if we want this to do something inside the world, we also have to remember to make an instance of that. In other words, drag and drop it into the world. And now we have spawned a new actor based off of this blueprint template that we just made into the world. So this means we could technically have multiple if we want, right? Like if I drag the second one, we're making multiples off of this actor class that we're about to define. So I'm going to delete my extra one here so that I only have my one. But make sure that it does exist inside the world, because when we start adding code, if it's not inside the world, we're not going to see the code. So just make sure you have one. And once you have this, if you want to customize the logic of what this actor will do inside the world, you have to open it up and you should get this menu over here. So there's a lot to look at. There's a lot of places to go. Just in case if you were on the event graph over here when it first opened up, you have a couple main panels that will be over here that you can use to navigate. We're going to start off with the viewport and talk about what that is. The viewport is mainly a way to visualize the actor. And if you have any visual components on it, you can actually move them around and position them in space. We don't really have that yet. We will in a second. But your viewport is for manipulating the components on your actor. So if you look over here on the left in this components menu, we can add new components. And components are blocks of predefined functionality that we can make this actor do something new. So we can give it audio, or we can give it a light, or we can make it rotate with a rotating movement component. We can do a whole lot of stuff. But what I'm going to do is I'm going to add a mesh component. So if you hit add and type in mesh, it'll give you a lot of options. We're actually looking for static mesh right here. So static mesh. And you can rename this whatever you want. Like your component doesn't have to have a specific name. It's usually best to call it what it will be. For now, it's static mesh, so it's fine. But if this was like the armor on a monster, we'd probably want to name it that. Okay, so that's the components menu. You can add, you can remove, you can reorder, you can parent, you can move it around in space if you want. This static mesh is empty by default, so let's actually give it a static mesh. If I go over to the right, this is my details panel. By the way, if you lose any of these panels, you can get most of them back from this window tab. Like you can see viewport and components and details. The event graph you have to get by double clicking over here under graphs, but we're not there yet. Anyways, if you have static mesh selected and you go over to static mesh and use the drop down, you can put any visual on this static mesh component that you want. So for example, I think with the starter content, there's a chair. We can use our chair here, and now we have our chair visual. We have our scene root, which is our pivot for our overall actor. But if you have a visual, you can actually reposition this if you want. Like I can rotate it and make it an upside down chair, make it real big, whatever. It's just a visual, so it doesn't really matter. I'm going to undo that. For now, I'm just going to leave it at origin, and I just want to show you that you can move it around if you want. The other thing is you can reassign materials for a mesh. Now we're using the appropriate material for a chair right here, but we don't really have to. If we do the drop down, you can type in, I'm going to do mi underscore, what's something we can assign. You don't really have to follow this part exactly. You can give it whatever you want, but mi underscore cube 01. Now it's a glowing orange chair. It's fine. Like we're just experimenting and I'm showing you where you can assign stuff. But I'm going to keep this for now. So this is the basics of how you start creating a blueprint actor. And there's a lot of other things you can do with components, but this is the viewport. This is how you can assign basic components, and this is how you can start to customize things on those components. Next, we want to talk about our event graph, because this is where most of our functionality will happen. And it's really important to understand where things start. So you're going to see these faded out default nodes probably. Begin play, there's an actor begin overlap, which we're not really going to use, and an event tick. So we'll go over these in a second, but let me just describe more things here. Over on your left, you're going to see some events and functions over here. Now, events and functions, you can make custom ones. You can see the ones that are already here. So I already mentioned begin play, begin overlap, and event tick. But if you double click a function, it'll just jump to it and highlight it. So once you have additional ones, or if you're poking around through the vehicle template ones, you can see them all listed over here, which is pretty good. Underneath that, you're going to see some variables. Now, these are some defaults. You see our static mesh is one that gets put down here. But eventually we'll start creating our own new variables, right? So if you wanted to create a new one, you could hit the plus button, you can give it a name, my new variable, you can give it a type. So what kind of variable is it? And you could change it, whatever. But the important thing that I want to show you is this compile save. So if you are changing the blueprint and you are adding new variables or new functionality, you need to compile. So you hit the compile button, and it makes sure that all your code doesn't have errors and that it is complete and working. And if it is, then we need to save our asset. So that gets rid of the asterisk. So I'm going to say this pretty often: compile, save, and then we'll test our changes. But I may not say it every single time. Just assume that if we make changes and we're about to test something, you should always compile, save, and then test it. Now I want to show you another thing. I'm actually just going to delete this variable. So select it, delete. We don't really need it. I just want to show you where you could make new ones. So in terms of navigation, you actually want to hold down the right mouse button. It's kind of like dragging, like you're holding onto the canvas and moving it around. The middle mouse button is zoom. The left mouse button is highlight and select. You can group select. You can click, hold control, click, click. You can do standard selection things, but just know that the right mouse button is where you move if you click and hold. Now, if you right click and you don't hold, then you're going to see a whole lot of nodes you can mess with here. And you can expand any one of these and you're just going to see a whole lot of stuff. Now, my point here is if I were to just click a node, there is so much information on a node. There's so many nodes already, and some nodes only show up after you pull off of other nodes. It gets very, very complicated. So if this part of Blueprints feels overwhelming, that's normal. Just know that I'm going to walk you through the nodes that we actually need. The vast majority of them we are not going to use for a very long time. Don't feel overwhelmed. Just try and follow along with what I do and you'll be okay. You should just know that there's a lot of stuff here and you're not going to be able to find it all. I guess the only other thing that I want to mention right now that's important to know is this little pin right here. Let me get my node back. I think it was some kind of collision node. Let's say get disable collision. Doesn't really matter. If you see this pin at the top, so it looks kind of like a triangle pointing to the right. This is called an execution pin. If you want something to run, like if I actually want to run this node, I have to hook into this execution pin. This means that we will do this, and then we will do this. These other nodes are usually for inputs, like we need additional information, then we could plug it into here. Or if we are doing a calculation and getting something out of it, then we can get the result by pulling off of here. But if we want to go to another node, right? If we want to go to another node, then we actually have to connect the pins. So all you need to know is that this is called an execution pin. And if you don't hook it in, your code's not going to run. Now I'm bringing this up now because at some point you're going to have all your code here, you're going to run it, it's not going to work, you're going to, panic. So it's getting me an error here because I actually need to give it something, but I don't even know what this node does, so it's fine. So don't worry about the compiling yet. I'm going to remove this. So if I delete, you see how it will remove my pins. Now my code's not going to ever hit here unless we connect the pin, right? So always remember to connect the pin. Otherwise, you're not going to move to the next node. And it's a pretty common issue to have. I want to show you one more thing. If I hold Alt and click, you can disconnect a node. And sometimes I may do that while I'm trying to, change something around. And I may not call it out every single time, but you should just remember that you can connect it, or you can hold Alt and click to disconnect from a certain pin. All right, so I'm going to remove any nodes I currently have, except I'm going to keep these main three that we started off with, our begin play and our tick. If you lose them, you can always find them again over here on the left. So the main important thing to remember when we're working with a blueprint is our entry point. We're either doing something one time right when we start the game. So it's going to be begin play. It'll just run through all the nodes one time as soon as this actor becomes alive. And then event tick is going to run every single frame. So this is like constantly every single frame all the time. Usually event tick is good for moving things based on button presses or checking something constantly. Just be aware of the difference between these two, right? If you can only do something one time at the very beginning, that's usually best. But if you need to constantly check something, then you probably should be using event tick for now. So just to show you, if I pull off of begin play and I type in print, you'll see a lot of options here. I'm going to select print text. The only difference between print text and print string is that text has a lot more options and like different languages and whatnot. So I'm going to print text and I'm going to say game started. And I'm going to compile save. And then just to show you, actually, I'm going to get rid of this actor begin overlap. And I'm going to show you what happens if we pull off of event tick. So I'm going to pull off of event tick. Again, I'm going to type print text and I'm going to type game running. If I compile and save, remember that this actor exists inside the scene, right? Because we put it here and we can see that there's a chair in the middle of our road, which is a little funny. So if I hit the play button, we should see game started because game started will run off of begin play. And then we're going to constantly see game running and it's just going to spam our logs. Let's try it. Hit play. You might not have even caught the game started over here, but you are seeing game running every single tick. So what I'm going to do is go back in. I'm going to disconnect our event tick so that just our begin play is running, but we know that this one's working. Hit compile, save, go back, play, and you see game started up there. So that's just to demonstrate that we can run some kind of logic off of begin play and event tick. I want to show you something else. If I were to duplicate this object, so hold Alt and drag it out, we have two, which means that each one will run that print statement off of begin started. So you should consider, what do you expect to happen when I hit play? Right, 2 games started. each one will run its own logic off of this one template. So each one that exists in the level will run its own, begin play and game started. That's pretty much how that works. But this is called execution order. And it's really important to understand in games because we need to know where our entry point is if we want to know where the logic will happen at what point during the game. Next, let's talk a little bit more about variables and how we can use them. If we go over here under our variables on the left and we create a new one, we can call this is playing, for example. And I like to use capitalization for each of the different words in my variables. And you can then assign a type. Now we have a lot of different types here, and the main ones that you're going to create is a Boolean, which is just a true or a false, an integer, which is like a whole number, 1, 2, 3, -5, 100, 1 million, whatever. Those are going to be integers. Floats, which are fractional numbers, so 3.5 and so forth. These are best for like multipliers and very small incremental changes, and text. You may also see string, but text is like a more complicated string. We have other ones that we'll mess with later, but these are the main ones. And you should also know that you can find a lot of other kinds of variables here under the object type, but these are the simple ones. So I'm going to select Boolean because is playing is either true or false. And I want to show you how you can get and set a variable, and they're both a little bit different. So if you select the variable that you just created, first, you'll notice on the right, it says, please compile the blueprint. When we create the variable, we need to compile so that it will get a default. If we compile, we can save too while we're here. You will see the default value over on the right. Anytime you create a variable, it needs to have some kind of default value unless it's an object type, which could be nothing or null. But for the Boolean and integer and float and all these other types, it will want a default value. And you can see that once you compile over on the right. So you can say by default, I want this is playing to be true. And we can check that. Or you can leave it at its default for false. Now, if I were to drag this into the scene, like let's say I want to use this as part of my node graph, I can drag it in, and when I release, it gives me the option to get is playing or set is playing. Get just means I want to look at the value and use it. So whether it's true or false, I want to do a test or whatever. Set means I want to change the value. So if it's false and I want to change it to true, then I would set it. If I just want to check what it currently is, then I would say get. So let's say I want to say set is playing. So right when we begin play, what I can do, I'm going to hold Alt and click, put this node after just because it'll read a little bit better. And so we can get practice moving things around. I'm going to connect this. We'll get the statement game started, plug it in. And right after we print this, we're now changing the value of this variable that we dragged in. So this is what a set node looks like. So each variable will display something different here on its set block. But for a true and false, that's basically just a checkbox, right? If it's checked, we're setting it to true. If it's unchecked, we're setting it to false. So let's set this to true after we say game started. So I'll compile, save. And for a get, maybe you could imagine that we want to check if the game is playing, and if so, then we can, print the statement. It is a little bit redundant for now, but I'm just trying to think of a simple example to show you. So let's drag is playing again, release it, and this time let's get is playing. Now this is a true or false, meaning that if we want to test something, we need to test a condition, like the condition being, is this variable true or false? A very common way of doing this in programming is called an if statement, but what they call it inside of Unreal Blueprints is a branch node. So if I were to pull off of event tick and type branch, you'll see a lot of different options here. I'm going to click on branch under flow control. And if you hover over, it'll usually tell you more, and you can hold Control Alt and it'll tell you even more. It's looking for a condition, so a true or false. And you can see a lot of times Unreal will color code the thing that it's looking for. So it's looking for a Boolean, so it's this red circle. One thing that will satisfy a true or false is a Boolean. So we can just plug this in, give it the input it needs, right? So check the value of this variable, true or false. If it's true, then print the text. If it's false, then don't do anything. You could also branch off of this and do something else if you like, but for now, we just want to split our code into two different directions. And if we are playing, meaning that we have set this to true, which should happen, because we're setting it up here, then we should see game running printed to our statement because we are checking it here. So compile, save. And the result is that everything will look the same. We just made it more complicated. Hit play and we're seeing game running. Now, just to show you, if we were to set this to false, right? So uncheck it, we're setting it to false. This should return and it's not connected to anything. So we should not see this print text. So again, we are setting the value of this Boolean to false and then checking and saying if it's true, do this. And if it's false, don't do anything. So it shouldn't do anything. All right, so we see game started. We saw it twice, which means we probably have that second chair. Yes, we have that second chair. So I'm just going to delete that. But anyways, this is how you can use variables. You can get them, you can set them. Just remember, anytime you need to look at a value of something, but you're not planning to change it, you want to get the variable. Anytime you want to change the value to something new, you want to set it. All right, so now that we're done with our tests, I'm going to move a little bit faster, and all you really need to do is follow along, but hopefully you will start to see the patterns of how we will build things as we go. So before we start building, I am going to delete out my test object just so it doesn't get in the way. We do not want to hit a chair in the middle of the road. So let's select that and hit delete, save our scene. So I want to make my win volume first. I'm going to right click, make a new blueprint class, select actor because it's something that will exist in the world, BP underscore win volume. And I will save it. So the next thing I want to think about is what do I need to do to get this functional? So I'm going to need some visuals, which we'll handle in a second. I'm going to want a collision volume to detect if the player entered. I'm probably going to need a new material, which we'll have to create. Actually, let's create that now. So let's go over to materials. We previously made this prototype material. If you select your material and you right click and you go to create material instance, we can build a material instance off of this material and it's much more optimized this way. MI underscore win volume. This is what we're going to use to display to the player, touch this thing and you'll win. I'm going to double click it and I want to override my color. So I want to make this probably green is a good idea. Green for good, I guess. I'm going to drag that to the top. So more of a lime green. And then I'm also going to make it emissive. You can put whatever values you want here, but maybe 5. Maybe this is overdoing it. But it's bright, it's shiny, it's green. I think that's fine for now. Maybe I'll make this just a little bit darker. Okay. So save your asset and then minimize. So now that we have our material, let's go back to our blueprint and open up our blueprint win volume. So inside of here, we want our visual, which is going to be our static mesh, and we want our collision volume. So to make our static mesh, I'm going to select add and type in cube. Now, theoretically, an artist can give us some final version of our art, but for now, for prototyping, we just need to work with something, right? We still need to communicate the gameplay. So I'm going to select cube and it'll give us a big cube. It's not quite what we want, so we're going to resize it to make it look like a big line that can stretch across of our track. So to do that, we're just going to scale this cube and let's change the Y value to something like 20. It's going to be very long, like a rectangle. And we also want to make it pretty flat so that we can set it on the track and not have it block the player. And so we're going to say 0.1 on Z, which is its vertical. So it's pretty flat, that's good. And then our materials, we're going to select our MI underscore, we're looking for our win volume, okay, the thing we just made. So we assign that. This looks pretty good. Let's compile, save, and let's put it inside of our map just so we can make sure, and I had tested some of these values before, so just drag and drop it in over there. And this is looking pretty good, right? So you can see it communicates to the player. This is a big, shiny green finish line. So now we need a collision to go over the top of it to detect the player. We don't need the player to touch the line exactly, just maybe they hop across it and that should still count as a win. So let's do that. To make a collision volume, we're going to select add, type in box because we want a box collision, not a sphere. So box collision. You see, since I had cube selected, it parented this underneath the cube. Technically that's fine. It doesn't really matter. It just means if we move the cube around, our collision will go with it. But I'm going to drag this out to the default scene root and say attach because I just want it to be side by side with our visual. Not super important, it'll work either way. So now that I have my box collision, I do want to position it so that it covers a space above the line right here. So you can scale it just like you did, with the cube under scale, but for brushes and things that, are more for collision or for detection, I actually like to do it on the shape down here. Either one will work. This is just a little bit cleaner. If you drag this, you can see it'll resize, so you can eyeball it if you want. But I have some values here that work pretty well for me. So 50, press tab, 1000, and what's the last one? 500. All right. So it makes this big shape, but I don't really want to detect under it, or I don't really care to. I really want to cover a lot of space above it. So I'm going to move it up and I'm going to kind of round that off. 500. Let's cover a little bit below it just in case. So 400, I think is pretty good. So we have this space above the line. And if the player crosses this, then we want to detect that they hit this collision. But the other thing we need to do before that is we don't really want this square on the ground, right? If I compile save, we don't want this square to actually block the player. Like they could hit this and then, you know, stop the car. So we're going to turn off the collision on this cube that we made over here. So if you select the cube, right, not the box, you want to select the cube and scroll down until you see collision over here in the details panel. Where it says collision presets, change it from block all dynamic, which means block everything that moves, to no collision. We want our collision volume to detect, but we do not want our mesh to block anything. So the player should just pass right through, and we'll mainly use this for collision up here. Now that we have our blueprint actor set up, we're going to add the functionality. The main things that we want to do, if we go over to the event graph, we want to detect when our box collision is overlapped by something. We want to test to make sure that the other thing that overlapped it is the player car. And then we want to do things like disable the input so the player can't keep driving the car after they win. Maybe we want to slow the car or park it. And then we want to display some text on the screen to let them know what happened. So let's do all that. The first thing we need to do is select our box collision component, not the cube, the box. And if you have that selected and you scroll down over on the right, and we can hook into any of these events that will automatically trigger based on gameplay. So for example, one that we have is on component begin overlap. This means when some other thing overlaps this box collision component, which is exactly what we want. So with box selected, I'm going to click on component begin overlap, this plus button. It'll create the node for me and it will get called automatically, which is great. And then I get all this information in response whenever this thing is called. So when something crosses this box collision. So what we want to do is detect the other actor. So remember, we're on our win volume. The other actor would be our player car. So I'm going to right click and type in get player pawn. And what this node does is it will automatically return whatever the player is controlling. If it's a car or a character or whatever. So whatever the player is controlling, if this is the same as this other actor, then this is the player character and we can continue. So I'm going to drag off of other actor and type equals. So equal. And if the other actor is equal to this actor, so pull from our get player pawn into here. And also just want to call out, there is also a get player controller that is different than get player pawn. Same thing with player character. We are looking for get player pawn. So just make sure that that's what you're using. If these are the same, then it'll tell us true or false. And off of this, we want a branch node, which is kind of like an if statement. So I'm going to pull off of my result of this, or true or false, and type branch. And you'll see this under flow control right here, branch. And it will automatically plug it in since I pulled off of it, or you can just connect it yourself and connect our execution pin. And if it is the other player, then it will let us continue. If true, I'm going to print, so print string or text, doesn't really matter. I'm going to do text and say player 1. So other things can cross this line, but if it's not the player, then it will return false. If it is the player, well, we should see this. So compile, save, go into the scene, press play, drive a little bit. Let's cross it, look for the text. Yes, up in the top left, player 1. All right, so make sure that that's working for you so that we can continue and add our functionality. So I can delete this now because I know that we're hitting this point in our code. Always a good way to check that your setup is correct before you add more logic. And the next thing we want to do is disable input, meaning that I don't want the player to drive the car around anymore. I want to force a stop. I'm going to pull off of true and I want to disable the input. So type disable input. You're going to see it pop up right here. So select that. And it's looking for two things. It's looking for a pawn or some controlled actor in the world to disable input on, and a player controller, meaning the player that this thing is associated with. You could imagine in a multiplayer game that we could have each person is controlling a different car. You know, we want to do it very specifically. So what we need is if we right click get player pawn. So this is the actor. So this is the car. We want to disable input on the car and let the player controller know that. So the player controller will stop controlling that car. So for this one, we're going to right click get player controller. right? This one, the screen one. So we just have to give it what it needs, and it usually will tell us. And if it doesn't, you can hover over, it'll tell you what type of thing it's looking for. Get player pawn, that's the target, and get player controller, that's the player who is giving the input. So let's disable the input. The other thing that we said we wanted is to park the car or slow it down. And I found a pretty handy function for doing this. And this is also an opportunity to talk about casting. So let me show you something real quick. If I back up and I go into my content browser and I go down to my vehicle template and blueprints, all these blueprints that you're seeing here have been customized by Epic to give to us. And so they're more specialized versions of all these things. Like a player controller, we have a vehicle player controller, or a vehicle advanced pawn that is a more specialized kind of pawn. So inside of our code, if we were to get our player controller, we're getting the generic player controller. We're not getting the vehicle player controller. But inside of the vehicle player controller, we have a lot of other things that we have access to do very specific and car related things. So let me back up into my original blueprint and my win volume. I want to get the player controller and then cast it. So in other words, test if this is a vehicle player controller, the one that we're currently using, which it will be, then give us access to vehicle player controller things, which is all this. So we're basically casting it to get a more specific kind of player controller if it is true. And in this case, it is, because that's the one they have set up for us to use in this game. So we have our get player controller. I'm going to pull off of this and say cast to vehicle player controller, and then connect the execution pin. If this player controller is a vehicle player controller, which it will be, at least inside of this template, then we can get the result of that and have additional options. So one additional option we have is if we do this, we can get the vehicle player controller, pull off of that, and we can use something called get vehicle movement component. All right, so we're pretty deep now. A little complicated, but it's all right. We'll walk through it. So inside of our vehicle player controller, we have a component. You can see down here under variables that gives us access to a lot of other things related to our car. Now, it doesn't expose everything, but a lot of functions, a lot of variables, and a lot of really cool stuff that we can use. So we're trying to grab this variable from the vehicle player controller. So I'm going to go back. Inside of this vehicle movement component, we can run a function called set parked. So you should see this. Make sure that you pull off when you start searching for this. So set parked. So pull off of that, type set parked, and this will park the car. We're telling it, park the car now, you have won. I'm going to connect my execution pin. So after we cast it, we then want to set park on this component that we got. So a little bit weird. Now we're setting the new park. We can set parked to true or false. In this case, we want to set it to true. So make sure you check that. And that's been a lot of work. So let's test what we've done so far. Let's compile, save, and remind ourselves what we're doing. We tested the box collision. If it is the other player, we're disabling input and we are parking the car. Okay, let's try it out. Hit play, go fast, and then our car should stop. Yeah, there we go. And the car gets parked. Great. Okay, so it's working so far, and that's how you can begin to add some logic to your win volume. Okay, so it's functional, but I think I would also like to display some text to the player to let them know that they just completed the level. So let's do that. If you go to the vehicle template and blueprints, this vehicle UI over here, whenever we press the play button, it gets spawned to the screen. That's how we're seeing this, number go up in the gears and stuff. We're going to reuse this vehicle UI widget for all the new UI portions that we put on in this programming week. So let's open that up, vehicle UI. The main thing to know here is that there's a designer view, which is where you are putting things on the UI and customizing text and position and stuff. And then the graph view, which is where you put in the logic and ways that you control the UI through code. We're going to stay in the designer view. So if you didn't see that at first, just know that that's how you get to this part. Now over here in the palette, you can choose a lot of different types of things to put in UI, but we're going to stick with the simple ones for now. And down below that, the hierarchy, this is the parent-child relationship to all the things that are currently in the UI. We are mainly just going to build stuff on top of this higher level part over here. This horizontal box, this is part of the car speed and gear and stuff. We're not going to mess with that. We're just going to put it right underneath the overlay right here. So I'm going to find my text. So go to your palette. If you don't see your comment expanded, just expand that and find your text because we're going to keep it simple. Grab the text and drag it into the overlay on the hierarchy. And this will put it on the top level next to this grouping over here. We have our text and I want to put it right around here. I want it to pop up in the middle center. So if I select my text and I go to my slot here at the top over on the right hand where the details are, this horizontal alignment, I'm going to align it to the middle and then the top on the vertical. And then if I want to give it some spacing for the top of the screen right there, you go under padding and I want my top spacing to be probably 200 maybe. That feels about right. So let's also change our text to be something else, maybe complete in all capitals with the exclamation mark. Want to see more information? You can expand this out. Okay, so complete, that's pretty good, but we probably want to make that a little bit bigger and let's give it some more color and other fancy things. Let's go to our color and opacity. If you expand this, let's change the color and opacity. So click that to maybe like a green. I'm kind of getting a theme and maybe we make that a little lighter. Don't want to go crazy with it. All right, let's zoom in a little bit. For our font, we want, I think bold italic would look pretty nice. Yeah, that's good. Let's also make it bigger, like a lot bigger. Let's do 60 under our font size. I also want to show you, you can add a drop shadow pretty easily, which is also kind of a nice touch. So if you go to your shadow offset and your shadow color over here, you can turn the alpha all the way up or you can just turn it up halfway depending on how subtle you want it to be. We'll go like almost all the way, hit okay. So that alpha is the opacity on it. It says A at the bottom on the color. And then we need to make the shadow itself bigger. So let's do something like 6, tab 6. That's vertical and horizontal shadow. If you zoom in, you can see it right there. So you can mess around with that if you want to customize it a little, but I think that looks pretty good. Now, the last thing we want to do, because the visual is fine, but we want to hide it at the beginning of the game and then enable it whenever we cross the win volume. So that means we're going to need to change this during the game, which means that this might need to be a variable. If you select the UI element over here in the hierarchy, scroll up to the very top, you'll see this is variable. If you check this, it'll make this a variable that then we can access inside of this graph view. So if you go to the graph, you can now see, well, it is not labeled because we were bad about naming. So go back to the designer, select our text block, F2, and type in win text. So now we have a proper name. If we compile and save, look over in the graph view, now it's labeled as win text. So we can actually get this as a variable in code if we access the vehicle UI, which we'll do through the win volume. For now, the only other thing we have to do is go back to the designer and turn it off by default, at least the visibility. So if you scroll down to behavior while you have it selected and you go to visibility, we're going to set this to hidden, meaning that it's not going to render into the game. We see it right now because we're in the UI editor mode, but during the game, we should not see it. So if I compile and save and minimize out, let's hit the play button. See, we do not see the complete UI, but what we want to do is set it to be visible as soon as we cross the finish line. So let's do that now. If we go back to our win volume, we want to access the vehicle UI and access this variable and set the visibility to be visible. I want to show you something. Inside of the vehicle player controller, we have access to the vehicle HUD, which is this vehicle UI thing that we spawn when we press the play button, which is where our variable is that we want. So that's the cool thing, is because Epic has already set this up for us. When our vehicle player controller creates the UI when we press play, it stores it as a variable so other things can access it. Meaning that in our win volume, if we have access to the vehicle player controller, we can then get the HUD off of that. So for example, since we've already cast to the vehicle player controller right here, if we pull off of this, straight from the cast to vehicle player controller and type in get HUD and down at the bottom, get vehicle HUD, we are getting the UI, right? This instance of the UI that we were just customizing from the vehicle player controller, which is pretty cool. It's just a handy little setup that's already there for us. We want to go inside of our HUD and access the win text variable. Remember, we made it a variable. So get win text after you pull off. And then from here, if you pull off of win text, we can type set visibility, and we want this bottom one, widget set visibility. Pull that over, pull that down a little bit, just clean it up. And our new visibility we want is visible. So compile, save, and try it out. Should be hidden by default. Should be visible once you cross the finish line. There we go. All right, communicate to the player. And the last thing we want to do is kind of a minor one. It's how to clean up our code, because we are starting to get a lot of nodes here where we're trying to troubleshoot this later on or add something to it. We're like, what is going on here? I don't remember what I was up to or what I was doing. And I want to show you how you can refactor your code to use events and functions so that we can compartmentalize this a little bit better. So what I want to do is create a custom event called win that I can call from right here, and then I can have all of this code inside of our win event. So let me show you. First, we're going to define the event. So if you right click anywhere you want and say custom event, and you'll see this add custom event, click that. And we're going to give this custom event the name win. All right, so what we want to do when we call the win event, it'll hop down here and run a lot of our nodes. So I'm going to come back up here, hold Alt and click where this disable input is. All of this I want to happen when we call the win event. So I'm going to zoom in here and connect it. All right, so when we win, all of our win stuff will happen. But we need to actually call the event, right? So this is what would happen if we called it, but we need to call it somewhere. So once we test to see if the player pawn has overlap with this box collision, then true. Where we were doing all our logic before, now we're just going to type win. And this call function at the top, win, this will now jump down here and run all these nodes. So now if we have a lot of logic that we want to do, we don't need to worry about all the specifics up here. We can just say, oh, well, it's win. And then if you double click it, it'll hop down to where all our nodes are. And then if we wanted to ever expand it later, we can pull off of that and do it. The other nice thing about putting all your logic inside of an event this way is that we are labeling what all of this is. This is all related to winning, which makes our code more readable. We don't really have to add a comment here because it's self-descriptive. We just say, oh, well, then we win. Okay, that's all I need to know. Or if you want to know more, you can double click and read through it. So this is just one way you can clean up your code, but I just want to show you how you could do that. So compile, save, and now our win volume is functional and ready for our designer to use. I want to show you how to use inputs in a very simple way for playtesting. The proper input system setup is to go through input mapping contexts and define actions and do all these settings for this to make it cross-compatible. It's a little bit too complicated to set up for a video like this, but I do want to show you how you can reload the level on a button press and quit the game as well. So we're just going to do it a very simple way, not necessarily the best and most proper way. So anything that's related to the vehicle player, not necessarily the car, right? The car is for driving around and braking. The player might be reloading the level or quitting the game. All of those kinds of actions should belong to the vehicle player controller. So if you open that up, I want to detect on two different key presses. Let's say on backslash, which is the slash right underneath your backspace key. Let's reload the level. And on P, so the keyboard P, let's quit the game. I know that doesn't really make sense, but Q is too close to our WASD, so it's the best we have. So right click and type in keyboard backslash, and you'll see this keyboard events backslash if you select that. This is a very simple call for just if this key was pressed on your keyboard. It's not cross-compatible across controllers and it's not set up for fancy detection. It's just a very quick and easy call. Not good for a giant game, but for a simple prototyping test, it is perfect for us. So when we press backslash, we want to reload the level. So if you pull off of press, if you type in open level, you'll see that you have two options here. We can open by object reference, which if we did that one, we could select a level to open. But the thing is, we want to open the current level, right? And maybe there's a way to convert this. I don't know. But another easy way to do it is if you pull off of pressed and you say get current level name, we can get the name of the level we're currently in, and we can pull off of that, say open level by name, and just pass in the current level's name. And it'll give us a conversion node, which is fine. All right, so just get the name of the level we're currently in and open that one. That is reloading the current level, so everything will reset. The second one's pretty easy. We're just gonna right click, keyboard P for the P key, and when pressed, you wanna quit the game. So on pressed, pull off, quit game. This is set up for multiplayer functionality as well. So let's just give it the specific player. It probably won't matter, but let's just minimize our errors anyways. I'm gonna right click, say get player controller and plug that in. Okay, so when we press backslash, which is again the slash underneath your backspace key, it should reload the level and everything will reset. And when we press P, we should quit the game, which is kind of like pressing escape in the editor, but that won't work if we ever decide to build this game out. All right, so hit play, and first let's try backslash. Okay, we reset. Everything resets. Our car, our level, everything just gets spawned again. Next thing is press P, and we quit. All right, so 2 little simple inputs. This is how you can use inputs for testing. Again, it's not the complicated and proper way, but it is very nice for testing functionality before you spend a lot of time cementing it into a more complicated structure. Next, we're going to make our collectible mechanic. It's going to be very similar to our win volume, especially the first part where we're setting it up. We need a material, a visual, a collision volume, and we're going to detect if the player touched it, and if they did, then we're going to respond with logic. So it's going to be a very similar setup. So let's do that part now. If you control space and I go to my blueprints folder under my underscore game, let's right click, create a new blueprint class. This is a actor. Our name is BP underscore collectible. I like to spell it IBLE, but some people do it ABLE. I'm going to do IBLE. Select it, Control S to save. So now we have our blueprint actor class. Before we go in and customize it, let's make our material so we're not getting too all over the place. Go to my prototype material, my M underscore, and then right click, create material instance, MI underscore collectible, again, IBLE, but just be consistent, whatever you do. Double click it and let's make this yellow. So global base color is yellow or some kind of orangey yellow. Pretty good. Hit OK. And let's make it emissive. Just always looks cooler that way. Let's give it 5. Maybe that's too much. I think it's just right. Too much is just right. So let's save that. Go back to our BP underscore collectible. Open that up. So we need our visual, so that's going to be our cube. Let's make it a cube. Technically, you can make a sphere if you want. It's all the same. Just make sure that it's sized appropriately, but I'm going to make a cube. Once you do the cube mesh, for now, we're going to keep it as a cube, but let's assign this material. So MI underscore collectible. Yeah, there we go. All right, looks pretty good. Compile, save. And the other thing is we want to turn off the collision on our mesh. We don't really want this to stop the car. We want the car to go straight through it, but we do want to get an overlap event. Now we could just overlap this specific mesh, but I like to actually make a separate collision for that so that we can make the overlap detection bigger than the actual mesh. I would call this adding padding to your mechanic. If they just kind of almost touched it, we give it to them anyways. It just feels better that way. For cube, come down to our collision presets and say no collision. Compile, save, and now let's add our box collision. So add a component, box collision, and select your box collision. We want to resize this. So scroll up to the top. I'm going to do it through the box extent, not the scale, even though I think either one would work. Let's do 100, 100, 100. So just a bigger box. Again, this is our padding. So if they almost hit it, then we still count it. And that's why I like to have my collision separate than my cube. Another thing you could do is you could drag the collision to be the root. So if I click drag my box and make that the root. Some people like to do this. It's pretty nice just because you're minimizing this extra pivot that's out here out of nowhere. But now I'm defining my root as my box. And if I wanted to, move the visual around, I could, but my box is now firmly in place. Okay, compile, save. And I think I'm pretty good so far, but usually at around this point, I want to pull it into my level. So drag your BP collectible into the level because I want to see how it is sized appropriate to everything else. And so let's pull it up from the floor just a little bit. Let's hold Alt and duplicate a couple. Right, just pull it out. Okay, so hit play. And actually that looks pretty good. Let's make sure I can go through. Okay, perfect. So we still need to detect if the player goes through the collectible, but I think that's about the size that I want, and I think the visual looks pretty good. All right, we have our collectible actors, but now we need to add the logic. So inside of our BP underscore collectible, let's go to the event graph. And what we want to do is we want to detect if the box was overlapped. So select box and scroll down on the details panel to on component begin overlap, like that, just like we did before. And we want to test if the other player has overlap. So again, I'm going to get player pawn and my other actor, if it's equals to, so equals, can it enter to autocomplete, plug that in, pull off the condition, branch. So if our player pawn is equal to the other actor, meaning since we're on the collectible, the other actor would be the car if something overlapped, then it was the car. And so at this point we can collect. Now I'm going to preemptively make my custom event, add custom event, and we'll call this collect. All right, so this one is our collect functionality whenever we call it. So let's call it up here. So if the player overlaps and is true, then collect, perfect. Okay, so just for testing for now, all we really want to happen is destroy the actor. So when we collect, let's pull off and say destroy and destroy actor. And by default, it's going to be self, or you could destroy something specific if you wanted. But if you don't put anything in here, it's going to destroy whatever blueprint this is associated with. So the collectible should destroy itself. Let's compile and save and test it out. These should disappear when we touch them. Okay, perfect. Now, we're not really doing anything. What we want to do is every single time we collect something, we want to increase an amount. Add 1 to our collect count, and then we can display it somewhere. And then we want to destroy the actor. So at this point, you might be thinking, well, where should I put the collect amount? You can't really put it on the collectible because we're about to destroy the collectible. So it's not keeping track of anything. It's going to be gone in a second. There are a lot of ways to do it. I think it makes the most sense to put it on the vehicle player controller and not the car, right? You could put it on the car, but once a car is gone, we no longer have a collectible count. So if I put it on the player, you think about it like Mario and lives. If you're playing Mario and you fall down a hole, you lose 1 life. So the player knows about how many lives it has. Mario is just one Mario who falls down the hole. So in this case, we have our vehicle player controller and we're going to make a collectible count on it. And then we're going to modify it whenever we get a collectible. So go to your vehicle player controller. If you're having trouble finding it, it's again down in the vehicle template blueprints and open it up right there. And we're going to make a new variable that we are going to increase. So on the left bottom, hit the plus button. We'll call this Collectible Count. And you should now be thinking, well, what kind of variable is this, right? What type is it? It's not a decimal, right? Our count is going to be a whole number, so it's going to be integer, right? We can't collect 2.5. Compile, save, and let's make sure that the details on the right, the default value is 0. Okay, it is. So we're tracking our collectible count on our vehicle player controller. Let's go back to our collectible. Now, every single time we pick up a collectible, we want to get access to the vehicle player controller and increase the collectible count by 1. So let's walk through the logic. It's going to look a little bit funky and complicated, but we'll talk through it. So we're going to collect. Then, in order to get access to the vehicle player controller, just like we did before, we're going to get player controller. We're going to cast to get the specific vehicle player controller. We'd have more complicated setups if we had a larger game, but for now, casting is fine for what we need to do. So plug in the execution pin, get the player controller. If it is the vehicle player controller, which it will be, then we can do vehicle player controller specific things. So now we should have access to the, if I get collectible count, we can actually get access to this variable now, which is what we want. So let's get collectible count. We'll hold on to that for now. But we actually want to set the collectible count to a new number, right? We actually want to increase the collectible count. There are a lot of ways to do this. There's like increment nodes and stuff, but I'm going to show you the more, the longer but more customizable way. So we do want to set it, meaning that we have to pull off of it again. So as vehicle player controller, say set collectible count. Want to set it to something new because we're changing it. Plug in the execution node. So we actually set it and run this node, and we want to set it to a new amount. So what is the new amount? It's going to be the current amount. So it's current collectible count plus 1 because we're adding 1 to it. We're not just changing it to 1. That would always set it to 1. We are taking the current amount and adding 1 to it. So we have our current amount, pull off of that plus, so hold shift and hit plus, or you can type in add. You can also use an increment, but this way we can actually define how much we want to add if we had collectibles worth different amounts or something. But anyways, we have our add node. So we're taking our current amount, we're adding, put in a number here. So I'm going to say 1. So add 1 to the current amount, and the result of this, set it. Okay, again, it's a little funky, but we're just taking the current amount, adding 1, and then sending that to be the new amount. And then let's just print the amount to the screen so that we can test it and make sure that it works. So I'm going to pull off of our set and say print string or print text, either way. And then the result of our set, so whatever we're setting our collectible count to, I'm just going to plug this in and print the value, and it's going to try to convert it into a string. So turn the number into a string, which it will print, and we'll see it on our window while we play. And then we still want to destroy the actor. So for now, we're just going to increase the amount, set it to the new value, print it to the console, and then destroy the actor. So we should see the number counting up each time we pick up a new collectible. Hit play. All right, watch the top left. 1, 2, 3, and then complete. All right, so our collectible count is functional, it's working and it's counting, and we are well on our way to completing our mechanic. All right, so it's not enough to just print our number to the console. We actually want to include our collectible count inside of the UI. I'm going to go back to my content browser, open up Vehicle UI, and let's put our collectible count down here. It's gonna be a little weird since we're gonna mess with vertical boxes and spacing and stuff. If it doesn't look perfect, that's fine, as long as you are displaying a number for the collectible count. That's all that really matters. I'm just gonna try to show you a slightly more complicated way of doing it, because you could just put it in the corner and that would be fine too. If I click any part of this in the designer view, you're gonna see that things are grouped under things called vertical boxes, which just helps you align elements vertically or horizontally for the horizontal box. So inside of my horizontal box, we have a couple of different UI groupings. We have our size box for our speed, we have a vertical box for our gear, and we're gonna make another vertical box for our collectible count. Go to your palette and you scroll to panel. Inside of panel, you're going to see something called a vertical box. Drag my vertical box underneath the horizontal box, meaning that it's going to put it inside of this grouping, right? So size box, vertical box, vertical box. Just make sure that it's underneath this horizontal box if you expand it. So that's our last one right here. It doesn't have anything in it. So let's put a text in it and an image. So scroll back up. We want our text. This is our collectible count. And then we want put an image in here, and we'll just leave it empty to represent our collectible, just a little square, make it a color. Let's also rename these. So select my text and we'll call this collectible count text. And for our image, we'll call this collectible image. Now let's customize a few things. If you select the vertical box, let's add some padding and alignment here, because right now it's all smushed to the sides and the top. So for my padding, I'm just gonna type 16 in this top. So it'll just put 16 underneath all these, or you can just type it in one by one. For my vertical alignment, I wanna align it to the bottom, like this other one. Click bottom align vertically, like that. It's pretty good. Next, we're going to change the image, so the collectible image right here on the bottom. Let's actually make that a square. So we're going to put it in the middle, so the center align horizontally. And on the bottom, I think that's where I want it. Underneath appearance, if you expand brush, you're going to see a lot of settings here. One, image size, the default is fine, 32 by 32. I think that's plenty. And we're going to change the color. So go to color and opacity, and let's try to match it to the color of our actual collectible. I think it's something like a yellow orange. I think that's good enough. All right. And now let's customize our text. So first, let's actually put 0, 0, since we're going to have numbers here. Let's just see what that'll look like. So 0, 0. Okay, that's a little bit better. Let's make the text just a little bit bigger. So 40, I think, would be good. So it sticks out a little bit. Let's also make it regular right there. I think just to give it a little visual differentiation right there. And then if you want, you can adjust the lower padding. So if you go up to padding, if you were to, on the bottom right here, if you were to put 16, for example, you could bump it up to be the same as that number. Actually, I think that's pretty good. I'm gonna keep that. So that was on the bottom padding right there. So you can customize how high it goes if you wanna try to match the top of these numbers at all. So let's compile and save. So we have everything named, we have it positioned where we want. Now what we need to do is we need to tie this number to the actual variable collectible count that we've been managing in code. So if we have 1, we want this number to display 1. So one way to do that, there's many ways to do that, but one way is to bind our UI text element to the variable value. So if you want to do it, that's just saying no matter what the variable is, just always make this number the same as what that variable is. So I'm going to select my collectible count text. And what I'm looking for is the text content. So find this, and somewhere over here, it might look a little bit different in future versions of Unreal, but for me, it's this little clip looking thing. If you select that, it'll say create binding. This is what we want. So click that. Now that will make a function, and hop over to the graph view. It'll make a function called get collectible count text. All that's saying is that anytime you try to get the collectible text from the UI, what do you want to do with it? If you give a value, it will display it properly. So we need to get the vehicle player controller's collectible count and plug the collectible count into this return node. And that's everything we need to make this binding work. All right, so there's a lot of proper ways to do it. We're going to do it the quick way just so that we're avoiding too many errors and issues since we're still just learning. The quick and easy way to do it is like we've been doing, get player controller, and then we're going to cast. So pull off of it and say cast to vehicle player controller. So the specific vehicle player controller with our collectible count, plug that in. And then what we need to do is pull off of as vehicle player controller. So now we have access to all of our stuff in there, like the, we can say get collectible count, perfect. And if we plug this into the return value, it will convert it for us. So it'll say, take this number, convert it to text, and then put it into the return node. Now, if we connect this execution pin, when we call this function, so the UI needs to call this function to update the UI, then it'll get the player controller, cast it, convert the collectible count to text, and display it, compile, save. This will always tie the UI to whatever our actual number is. And again, you know, this is happening pretty often, and we're getting the player controller a lot. So not the most optimized way, but it is totally fine for now, especially for prototyping. You'll learn more complicated ways to do these things if you decide to take more scripting courses. So compile and save. Let's go back. And honestly, I think that should work. If you hit play, see 0 collectibles down there, pick them up. All right, 3. And it looks like it's functional. So our collectible count is working. It is displaying the number. I think the only thing I want to do is go back to our BP collectible, and I'm going to take out this print string. We don't need it anymore. I'm just going to have, after the set, just destroy the actor. We're not printing the value anymore since it's displaying on the UI. Compile, save, make sure everything is saved. So maybe at this point you do a save all and test it out, and it should be working, and you should be done with the collectible. So I've talked it over with the designer, and they've decided they really, really want a stopwatch. So we're going to try to squeeze that in here. So a stopwatch would be if we hit the play button, and our elapsed time will count towards the top and tell us how long we've been taking in the level. And we want to display that in the UI. And when we cross the finish line, stop counting and show our final time for how long it took us to get through the level. We're going to open up the vehicle UI and go back to the designer view. We're going to put our count at our top for where a stopwatch is. So let's drag in our text. We're just going to put this on the overlay, just the root. All right, so just make sure it's not under another box here. It's just right at the top or down at the bottom underneath overlay. So right here, let's do a kind of a sample pass. So we will say 00 colon 00 colon 00. So it looks something like that. Now let's center it. Let's display it kind of above the complete. So once you do center alignment and vertical at the top, let's put the padding from the top about 50. So it's slightly below. I think that's good. Scroll down. Let's make this text a little bit bigger. So under font, let's do italic, maybe 40. And I think that's good. Let's actually give it a name. So go back to your hierarchy and rename this timer text, compile it, save it. Because we are going to manipulate this through code, let's make it a variable. So at the top of timer text, where is variable, do the check mark. Again, compile, save, and go into the graph. All right, so inside of the graph, we can actually manipulate this. Right now we're inside of the get collectible function. We don't want that if you double click on the event graph. Now we're outside of it. Okay, so you can see that there's already stuff here that's displaying the speed, and Epic has already set all this stuff up for us. What we need to do is let's look at the pattern of how they're doing it. So they're making a custom event, so update speed, update gear, and they're calling these things from the vehicle player controller. So in the vehicle player controller, an event tick, they are getting the speed and updating speed, getting the gear and updating the gear. We're going to do the same thing and then update the timer. So we're going to set up our event over in vehicle UI, and then we're going to call it from vehicle controller. So let's do that. Let's right click, create a new custom event. So custom, add custom event. We'll call this update stopwatch. Now, in order to do this, we need to track the current amount of time that's passed. So in order to track a value and store it, we need to make that a variable. So let's go over to our variables right here, hit plus. This is elapsed time. So it's going to be a decimal point, right? We're counting milliseconds. So it's going to be very, very small. We'll make that a fraction. Let's call this elapsed time. Make this a float. Let's compile and save. That should default to 0. Every single time we're updating our stopwatch, we are getting the time since the last update, so last tick. We'll call that delta seconds. So let's actually right click, get world delta seconds. All right, so when we update the stopwatch, we want to set the elapsed time to a new value using the world delta seconds. So drag our elapsed time. We do want to change this since we're counting up. So set. Let's plug it in. And our new value is going to be the current value. So pull elapsed time and get it. Set to the current value plus, so add the get world delta seconds, which is basically the amount of time in seconds it's passed. So it's going to count up in real time in seconds and add that value to the existing elapsed time. So it should just look like a value that's counting up by very small amounts in real time. So the result of this will plug in. So we're setting the value, and now the next thing we need to do is display it properly, because it's kind of weird, but we need to actually display it into minutes, seconds, milliseconds, and so forth. There is a way to do a conversion for that, but Unreal has a handy function that will do that for us, and we're just going to use its default one, and I think that'll be fine. So after we set this, we want to set the timer text to something. So let's drag our timer text off, so get timer text. And this is a link to our variable that we made earlier. So inside of our designer, it's a link to this variable, and we want to access this and change it to something. So we want to pull off of our UI element, our text element, and say set text. So this is how we change the text at the very bottom, set text. It's kind of weird to say. We're going to execute this, and it's telling us what it needs. We just need to give it the new text to set it. So we have our amount. We could plug this in, but it's not going to format it properly for us. So what we're going to do is pull off of our elapsed time, like right after we set it, this new value that we get. So we're counting up in real time. We're going to type in time seconds to string down at the bottom. So this is going to convert this amount. So this, like if it's 100, it's going to convert it to a second. So if you hover over, convert a number of seconds into minutes, seconds, milliseconds. This is what we want. It's just converting our float so that we can format it a little bit better. Pull off of this and plug it in to text string, and then put the final amount. Let's just kind of drag this around, make it a little nicer. All right, there we go. Pull all this down a little bit. So we have our timer that's counting up in real time in world seconds. And then the result of that, we're converting into a format that we can display in the UI. So it's not 100, it's 60 seconds plus 40 seconds, right? 1 minute plus 40 seconds. And we're converting it and then putting the result of that into the text. Kind of weird, kind of complicated, but it should all work. But we're missing one piece, remember? We need to call this every single frame. And just like everything else here, we're calling this from the vehicle player controller. So let's go back to our vehicle player controller where they have event tick. They're calling update speed. Yes. Update gear. Yes. Pull off of this and say update stopwatch. All right. Compile. Compile. We need a target. So the target, because this vehicle UI has our function, we actually need to give it a target. So we need to get access to the vehicle UI, which is this component over here inside the vehicle player controller. Just drag this vehicle HUD in. Yes, this is what we want. Access the vehicle HUD and update that stopwatch, the one right here. So I forgot about that. Compile, save, cross your fingers, cross your toes, hit play. It's working. Awesome. I love it. Okay, so it's working, but we see that when we cross the finish line, it continues to count. So that's the next thing that we're going to have to fix. All right, so the way that we're going to fix this is we're going to track a Boolean on our vehicle player controller, and we're going to call this is racing. And so while we're racing, so if this Boolean is true, we're going to update the stopwatch. And then if it's ever false, so we're no longer racing, we are not going to update the stopwatch. And then inside of our win volume, we'll just, whenever we win, we will turn the Boolean off and say we're no longer racing. So when we do our check, we will no longer update the stopwatch. So let's see what that looks like. I'm gonna make a variable on my vehicle player controller, and we're gonna call this is racing. Now in a bigger game, you could put this on a game mode or some other thing, but this is fine for now. Say is racing. And the type of this variable is going to be a Boolean, true or false, whether they're racing or we're not. Compile and save. It will default to false, which is not what we want. We could say default it to true. So yeah, we want to race at the very beginning. I could imagine a racing game where we have a countdown for when we, start the race. So we could, for example, default this to false. So let's turn that back off. And off of begin play, like whatever our begin play is here, it could change over time if the vehicle template ends up getting changed. But find your begin play node, go all the way to the end, wherever that is. And right here, this execution pin, I'm going to drag my is racing set. We're going to set it to true, right? So connect that and say check. Yes, we are now racing. This way, if we wanted to turn it on at a specific point in time, like we could delay a certain number of seconds and then enable it, we could, but we're just leaving the option open for ourselves. For now, we're just going to do it instantly on begin play, and that is fine for what we need. So compile, save. So we're going to turn it true right after begin play, no matter what the default is. And then over here, we're going to check. So when we update our gear, we're going to pull off of that branch. And we're going to branch, and we want to check if is racing is true. So drag is racing. This time I'm going to show you can drag it directly to the input pin, and I'll just plug it in. If is racing is true, meaning we're currently racing, then update the stopwatch. If this is no longer true at any point, it will not update since it'll pull off a false. So set it to true when we begin, right? And then as long as it's on, update it. So all we need to do now is set it to false. So when we're no longer racing, is racing is false from our win volume. So let's open our win volume over here. Okay, that's a lot of stuff here. In our win event at the very end, we're setting our visibility, and then we're saying we need to get access to the vehicle player controller, right? This one right here. And we need to turn the Boolean to be false. Now, you just have to remember where we're trying to get to. So we're trying to get to this is racing variable on our vehicle player controller. So now we got to figure out how to get from win volume to vehicle player controller. Well, we've already gotten there over here, so we can just pull off this and then plug it in. That's probably the easiest thing to do. So let's do that. Very important that you have to pull off of this and then type set is racing. And you're only going to see this if you're pulling off of this node while you type. If you just try to right click anywhere and type, you're not inside of the vehicle player controller to access the variable. You are only inside of there if you are pulling off of this, and you can now see it. So I just pull off of that, type it in. You see how the line gets kind of messy right there, like it's hidden behind. Let's connect this node. You can fix this by double clicking on that, and then you get a little, they call it a reroute node, where you can pull the line wherever you want. So we can pull it a little bit over there. It's a little bit cleaner, right? Or you could find other ways to pull this over here. You can do it again if you want. Just want to show you reroute node. So we pulled off of that, set to false, meaning that the moment that we win, it's set to false. We will no longer update the stopwatch. That was a lot of steps, but I think it's going to be a really cool effect. So it's play, go, 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 collect. And it stops. And I think that feels pretty good. We're displaying the final score, essentially the time of the player whenever they cross the win volume. All right, so we've spoken to our designer again, and they're telling us, yes, everything is awesome, but it would be really cool if we could have a little boost pad like they have in Mario. It would give me so many options for my level design. And can you please make it? And yes, we're going to try to make a boost pad. In this one, I am going to move a little bit faster, not only to save time, but because we've done a lot of this before, you've seen the pattern. So follow along, and you don't need to understand everything. So let's go through it. Let's create a new visual color for our boost pad. Select our material, right click, create material instance, MI underscore boost pad. Control S to save. Let's open this up. I think I'm going to make this one purple. Check our base color, make that purpley, pull the brightness up. Again, I like everything to be emissive, so let's just make it emissive. Do 3. No, that's too much. Let's just do 1. Perfect. Control S to save. All right, minimize. We have our material. Let's make our blueprint. Go to blueprints, right click, blueprint class, actor, BP underscore boost pad. Control S to save. All right, so we're doing our setup now. Double click to open. Remember, we need our visual and we need our box collision. So let's do that. Let's do a cube again, and we'll stretch it out. Scale out the transform. So I think a good value would be 2, 5, and probably 0.1. We'll make it really flat again, vertical. Okay, 0.1. What I like to do at this point is compile, save, and put it in the world. Control space, just drop it in the world. So let's actually move this right in front of the collectibles right there. And I think that's a pretty good size. So let's go back into our boost pad. Let's give it our material instance on our cube. mi underscore boost. Boost pad, we need to turn off our collision, don't forget. So scroll down to block all dynamic, change that to no collision. We need our box collision, so click add box collision. I put it on the cube. Let's actually reattach it, default scene root, and say attach. Let's just keep these separate. And we need to resize our box collision right there. So let's see, what are some values? Box extents, we just want to make it match more or less what the pad is. So let's try 100, 300, 100. We can even move that up a little bit. So let's move it up about 100. And you'll notice that my boost pad is a little bit bigger. Like the collision is a little bit bigger than the visual. I think that's a good thing, because if they almost barely touch it and they think they touched it, but they really didn't, we still want to give it to them, right? We always lean towards benefiting the player when we can. So we'll call that padding. Looking pretty good. Compile, save. Next, we add our logic. So we want to, inside the boost pad, go to the event graph. And I'm going to close these other tabs out so that we don't get too confused. All right, we need our collision event. So let's select our box collision. Scroll down over in the details panel for on component begin overlap. We're going to get our player pawn. So right click, get player pawn. And we're going to pull off of other actor, not other comp, other actor, equals, pull in our get player pawn. So if the other actor is the player pawn, pull off of the condition result, branch, then our player has touched the boost pad on the collision. All right, great. And we're going to make a custom event now. So let's right click, custom event, add custom event, call this boost. So we'll put this down here and make sure to call this new event boost. We succeed our check, so we boost. All right, so we're calling that. Jump down here, compile and save. This is when things start to get a little weird. All you need to do is follow along and watch carefully. There's a lot of little things that can go wrong if you forget a checkbox or something. So we're gonna get our player pawn. So what we're trying to do is we're trying to get access to the vehicle component and increase the speed. But we also want to make sure we're not already exceeding the max speed so we don't like shoot through the level. So we're going to do a check before we add our force. So let's actually get our current forward speed. And if it's below a certain amount, then we will boost. Get player pawn. We're going to cast it to vehicle advance pawn. Plug that in. So what we're trying to do is we're trying to get the forward speed in miles per hour. If you pull off a vehicle advance pawn and you type in get forward speed miles per hour right here, if you click this, it's going to automatically convert it to the vehicle movement component. So just click that and it'll just give you a lot of nodes, and that's fine. Off of as vehicle advance pawn, we're going to get the forward speed miles per hour, and we're going to test. We're going to say, are we moving forward at a speed that is less than a certain amount? If it's less than a certain amount, then we will allow the boost. If we're over this amount, then we're already going too fast. We don't need the boost. And we can cap it in other ways if we want, but for now, just drag off of get forward speed miles per hour and say less than, equal to, less equal. And this is our max speed amount. Depending on how you adjusted your car based on how I adjusted mine, yours might be different. I'm gonna say if we're going less than 100 miles per hour, then allow the boost. If we're going over 100 miles per hour, that's way too fast. We don't need the extra boost, so that's fine. And then after this, we want to branch. This is kind of like an if check. So if, plug that condition in, plug our execution node, If our forward speed in miles per hour is less than or equal to 100, so we're going under 100 miles per hour, then we will allow the boost. So now we boost. In order to boost, we need to make a boost strength, and maybe the designer will want to control how strong the boost pads are. So let's make them a variable to do that. So hit plus, and our new variable will be called boost strength, and we'll make that a type float. Compile, save. And this is going to be a very crazy number, and it's just because physics can get very crazy sometimes. If you select boost strength and you go over to the boost strength amount, I'm going to set mine to 300,000. 300,000. 300,000. You can do a bigger or smaller number than that if you like. I just have not tested significantly bigger numbers, but this is what I'm going with, and this should be fine. But if you want to tweak that slightly, you can. So what are we going to do with that number? Well, when we boost, we want to get the player pawn's forward direction and add a very big force in their forward direction. Right click, get player pawn. I want to get the player pawn's forward direction. So pull off of that. Get actor forward vector. Okay, that's fine. So we have the direction of the player, and that's going to be whatever direction they're facing, if they're going that way or opposite way or whatever. Get the direction and multiply that by the boost strength, and that'll give us a very long line, a long force line at a certain direction. So if we multiply a line by an amount, we get a longer line. So pull in our boost strength, say get, and then I'm going to pull off a boost strength and type multiply. Just use the bottom one right here, multiply. And we're going to plug in our get actor forward vector. So multiply our strength by our forward vector. It'll convert it. And this is our final calculated force. We just need to apply it to the player. So what we're going to do is, as the vehicle advanced pawn, pull off of that one more time and type add force. And you're going to see this top one, add force mesh. That's the one we want. All right. So it's going to add a force to the car. So off of true, plug that in. I'm going to move everything down a little bit. But it's looking for the force to add, but we've already calculated this, right? So I'm going to move this over, and we're going to plug in the final force amount that we calculated into the force. The last thing is accelerated change right here. I'm going to check that. It's just going to be a more instant change. It's not going to incorporate mass or anything. It's just going to launch at a direction full speed. So it's going to feel a little bit better, I think. Save. And I think this is all the functionality. The only other thing I wanted to show you is, because this is getting a little bit messy, I want to show you how to make comments. So you can actually do little comments here. So if I were to, for example, right here, let's say on this branch. So if you click this little triple dot, you can type in a comment. So check if we're not above max speed or something. And maybe you could even turn this into a variable called max speed. Quick way to do that is to right click, say promote to variable, and give it a name, max speed. All right. Super easy. You also want to compile and save and make sure that your default is the same that you already had in there, but it should be. Okay, so what I want to show you is you can leave a comment there, or you can highlight a lot of nodes like this, and you can hit C on the keyboard for comment and call this check max speed. Now, if I pull this around, it pulls all the nodes inside. That's pretty handy. I'm going to pull all these over and hit C, and we'll say boost. This will be handy later if we add more functionality here. So you can also change the color if you want. Like maybe we want the boost to match the boost color, make it purple. So this is another way that you can clean up some of your code. So let's check it. So compile, save. All I really need is a boost before. Let's actually do 2 in a row. Let's launch across that finish line. All right, save, play. Let's do it. Oh yes, a good boost. All right, perfect. Our designers will love it. So this is our boost pad. It is launching us a direction, and we can use this throughout our level to get a lot of speed and strategic places, which I think will help the level design a whole lot. Before we start, if you have not backed up your project so far, you should do that now. So find your project file, and you're going to turn it into a zip file, just like we've been doing up till now. Once you have your backup, then you're going to name that whatever you like, and then put it somewhere just in case you need it. By the end of this week, we're going to have our vehicle game with a lot more game feel. So a lot of audio, we'll even do some slowdown, some particle effects and bursts and things. I'm going to show you what that looks like very briefly. So you'll have something like this. So there will be a lot of extra effects, and we'll learn how to implement all of that in this week's assignment. During our game, we want to play some music to create a feeling for the player. It could be very intense and high action kind of feeling, or it could be very chill and relaxed and peaceful drive kind of feeling. Either way, we want some kind of music, and probably most of you are not musicians. So one way you can find music to use for your games, I'm going to search for something called royalty-free music. And there's a lot of sites you can download music from. One that I found towards the top is Pixabay, but there are definitely others. And then you'll want to preview the tracks and find some kind of music that you think might sound good in the background in your game. I may start to get some ideas for the kind of feeling I want to create. I don't know what funk is, but let's try that. And you'll see some stuff here and you want to preview. Let's try this one. Okay, perfect. Actually, we'll just go with that. But you can find other music tracks here or on other sites. Sometimes you'll need to create some kind of login to download it. So do whatever it takes to log in, create an account, and download your royalty-free music. One other thing you can do, if I start a download here, a lot of times royalty-free music will have some kind of license attached to it. So if you click on that, it will tell you how you can use this music. Sometimes it's attributing the artist, sometimes it is not, sometimes it's commercial, sometimes it's not. Make sure that you take a look at the license for wherever you get the music if you want to be extra safe. But for now, I'm going to download. And in my case, I believe it already downloaded over here. And so you can find it right here. Take this track and put it somewhere. I want to point out that this is an MP3 file, and traditionally the highest quality music tracks are going to be WAV files, and Unreal used to not accept anything except for WAVs, but now it will accept MP3s. If you can find a WAV, even better, but if you get an MP3, that's fine. I'm just going to use an MP3. So I'm going to put this on my desktop or somewhere else that you'll remember it in the short term, because we're going to import it into Unreal in a second. Next, you want to make sure that you're inside of your project, and we want to import our music. Now there's a lot of ways to do that. First thing I'm going to do is right click in my _game folder and create a folder for audio. And this folder will hold all of our sounds and music and anything else related to audio. So we can import some tracks. So click the import button, navigate to wherever your track is and open it up. So first thing, Control S to save your asset file. You can preview it here if you want. All right, it's working. And I'm also going to double click this, and there's a setting for looping that when you're playing a music track, you want it to continue playing once it reaches the end. So for music specifically, you want to double click that asset, go inside and find the looping checkbox and say, yes, I do want it to loop. So I'm going to do a little check there. Save the asset, exit out. As long as you have looping, you're pretty good. And we have our music found and imported into our assets. We have our music track. I think I probably want to give this a better name too. So let's rename with F2. We'll just call this funk music. You could name this after the level later on if you like. But we have our funk music, or whatever name is appropriate to the music track that you find. And if you take this and you just drag it into the level, it will create a new ambient sound inside of your level. It'll have the little music player, and that's pretty much it. So one thing I like to do is move this to world origin. So 0, 0, 0, just to make it easier to find. Otherwise, you can just find it through the outliner over here. So now that we know where our music player is, another thing that I like to do is just move it upwards a little bit so that we can see it and it doesn't get in the middle of the geometry, but it's at 0, 0, and then some vertical. So we'll have a lot of things floating up here if we need to select them in the level, but that's just a personal preference. Our music is going to be pretty loud if we hit the play button. Right, usually you don't want your music to be the loudest thing in your level. You want to hear the gameplay sounds also. One starting point for music, it really depends on how loud your music is to begin with, but I almost always put it to 0.5 or 0.4, 0.3, somewhere around there. I'm going to leave this one at 0.5 since I do want it to be a little louder just to emphasize the energy, but I think anything between 0.3 to 0.5 would be appropriate. The other thing you want to do is you want to turn off allow spatialization. This means that it will just stay the exact same in your left and right speakers. You're not going to get any kind of weird shifting, so it'll sound like music should. The other thing to check, which actually should be checked by default, but we just want to double check it right here. Auto activate means that when this music player in the world is placed and when we press the play button, it will start playing its sound at the moment that this actor becomes active. So it will automatically start playing our music. If we were to turn this off, it means that we would have to tell this ambient sound to play. Otherwise, it's just not going to play its sound yet. So that's better if you want to, switch music at some point. But we just want it to play right at the beginning. So we're going to make sure that auto activate is on, which it should be by default. And that's it. If you press play again, right, it's already starting to feel a little bit better. Our volume should be appropriate, and we can't fully gauge that until we get some sound effects, so we will do that next. For gameplay sounds, you have two different ways you can approach it. One is you can use a sound library or actually record sounds and use real world sounds and try to bring those in, or you can process them. Another thing you can do is use a synthesizer to create simple sounds to use for testing in your game. So let me show you what that means. So I like to use a free synthesizer called Chiptone. Type in Chiptone. One of the top links here, if you click that, it's this little keyboard and you can press the buttons to make different sounds. Right, you can turn on and off effects or harmony, delay, and a lot of others. And so what I'd like to do is get a very generic sound for prototyping so I can tell if a sound is there, or just add the basics of an audio feel. And then the sound designer can come back in later and make a nicer, fancier sound to replace the placeholder sound that I'm using. For now, I still want a sound because it's going to be very important for the game feel, but I can always make a better one later. So we're going to use this for our sound effects in our game. Let me show you how easy it is to do. So we want 3 sounds for our game that we're going to implement. One is a collectible pickup sound, so kind of like a coin, right? Maybe that'll even do it. We want a boost pad, so that's going to be kind of a big bursty thing. So I'm thinking maybe a boom, right? Any one of those would be fine. And then a win volume. So it's going to be kind of like a 1-up. So something that feels really nice or much better than a single blip. Right? Still kind of cheesy, but it's enough for now to communicate what is happening in the game. And then again, a sound designer can come and replace it later. So what you could do is you could, for the collectible pickup sound, you could click the coin a couple times. So let's say you find one that you like. Simple, like a Mario coin. You can add other effects to it if you want. So harmony is sometimes a good one. Maybe that's a little bit too crunchy, but you can also pitch it up or down too a little bit. All right, that's fine. Once you're done with the sound, you can actually save it out with the save.wave button right over here. So save.wave. Click that button, you'll get the download, go to the folder, and rename this sound Collectible Sound. So now we want one for our boost pad, so like a big boom. I'm gonna do a boom. That sounds pretty good. I'm going to add a tremolo, which will make it kind of fade in and out a lot. All right, it's sounding very boosty. And let's add harmony to give it some more layers. I think that sounds pretty good. So let's save that one out. So again, you can see how quickly we can make sounds for testing. And this is plenty to get our mechanics started. Boost pad sound. And then we want one more. Win volume sound. So let's do a 1-up. I'm going to turn off tremolo that I had before. All right, when you find one you like, so this is one that I clicked around a little bit. I think that sounds pretty good. I'm gonna save that one out. All right. And we have our win sound. So 3 sound effects is gonna add a whole lot to our game. I'm going to put these on our desktop again, just so we can import them easily. Put them over here. And we're gonna import these 3 sounds inside of Unreal. So if you come back, come over to import and you find out wherever you save them. I'm gonna control and then click these 3 sounds, open them up, and here we go. And let's save all of them. You can do save all if you like. So you can test them out. As long as you like those, you can keep playing around and get better sounds if you want, but this is all I need to get started. Next, I want to introduce you to something called MetaSounds. So MetaSounds is a very robust system for manipulating audio at runtime through like little blueprint style nodes. So it's kind of like scripting for audio. And we're not going to do very much with it, but I did want to bring it up because with a collectible sound, so I'm going to hit the play button. You could imagine that if we had a lot of collectibles right in a row, if we heard that exact same sound 3 times back to back, it would sound kind of odd. And we want a little bit of variation in the pitch and the volume maybe, and just adding a tiny little variation so that when we play the sound, it will automatically pitch it slightly up or slightly down, will prevent us from having these weird overlapping issues inside of our waveforms. So I want to show you how you can do that using meta sounds, but we're not going to do it on the boost pad or the wind sound. I'm just going to show you one time on the collectible, since I think that one makes the most sense to use. And it's kind of a powerful tool once you know about it. So to make a meta sound, it's just like any other asset. You're going to right click and go to audio and meta sound source. And let's give this a name, ms_collectible sound. So just give it a little prefix. Control S to save it and open it up. And this is going to look pretty familiar with Blueprints. It has the same navigation with your right mouse button to move around and all the other stuff. We are trying to play the sound and we have it right here, and then we can do some manipulation to the sound, and then we can send it out, and then we hear it inside of our speakers. So our goal is to get the final sound out over here and to call this on finish so that it can go on to other parts of the system. So we need to connect these two nodes from this input. So let's see how we can manipulate this sound just a little bit. The first thing we want to do is actually play the sound. So we need something called a wave player. I'm going to drag off and type in wave player, and you're going to see a lot of options here. A lot of times for sound effects, you just want mono. For music, you probably want stereo. Either of these first two would be fine. I'm going to do mono just because it's simple. So that 1.0 mono. So we're coming in, we are playing the sound, and then our out can go directly into out, and then our unfinished can go directly to unfinished. Now this will just play the sound if we give it a wave asset, so we need to do that too. So click wave asset and find the collectible sound, type in collectible, all right, collectible sound, perfect. So go to the next node, play the sound, and then go into the out. So this just plays it. So this is our neutral point, but you can actually test the sound right up here with the play button. You see, if I try to spam it, it sounds too similar. So let's add some pitch variation. So to randomize the pitch, we can send in a value to the pitch right here. So what we want to do is we want to get a random amount between close to 1 but right under and slightly above 1, and then put the result into the pitch shift, because our default pitch is going to be 1.0. So let me show you what that looks like. I'm going to drag off and type in random float. So this is a node that will let us get a random value between two different amounts. So we'll pull that over. So our minimum is going to be right below 1. So we could say 0.95, for example, so like 0.95. And then for our max, we could say 1.05. So right below 1, right above 1 is our max. We'll plug in the value right there, and this should give us a randomized pitch. Let's try it out. Kind of hard to hear, right? Like you can make this more extreme if you want. Let's do 0.8 and 1.2. Might be able to hear it a little bit. You can push that even further, but I think I'm okay with this. The next thing we would want to do is slightly adjust the volume. So that's how loud or soft it is, not really the pitch. And the simple way to do that is just to multiply this out by a number very close to 1. Same thing that we did over here. So we'll drag out from the beginning and pull out another random float right there. And we'll do the same thing. We can keep it a bigger range right now, 0.8. 1.2. I usually do 0.05 increments, but this is fine. Better for teaching anyways. So let's pull from our out, and we're going to look for a multiply. So type in multiply, and we want to multiply audio by float. So this top one. So we give the result of the random number close to 1, and we multiply it and pull off. This is what we want to send into our output. So we're basically just taking the result of all this and multiplying it by close to 1, and that will give us a slightly different volume. So let's test it out. Right, you might be able to hear it. Again, it's subtle, but it's just enough difference that it's not going to overlap our sound waves, which is exactly what we want. So make sure to save. And this is an example of how you can get some pitch variation in your sounds. But again, we really only need to do that for our collectible sound. Our boost pads are going to be pretty spread out, so I'm not too worried about that one. And our wind sound, there's really only one. So I think this is all we need for our sound setup. All right, we have our sounds. Now let's play them. So let's start with the boost sound, since that one's the most straightforward. Go to your boost pad, your BP_boost pad, and open that up. Inside of Blueprints, we're going to do our boost, and then we're going to play the sounds. So once we've done all of this, we want to pull off of add force and play the sound. There is a node for this called play sound, and we can either play sound 2D or play sound at location. I think I'm going to do play sound at location. So this one's in the world, and 2D means you can hear it no matter where it is. But let's play it at the location of the boost pad. So once you have this node, you want to select a sound. So it's going to be our boost pad sound. I see it right here, but you could also search for it if you like. Boost pad, and it needs to know where to play it. I want to show you a very easy node. I want to play it from the location of this boost pad that I'm on. So if you right click and say get actor location right here, you can just plug this into our yellow location node, and this will give it the location of the actor that this blueprint is attached to. So this boost pad, it'll play it at that location. You could also play it at the player pawn's location if you want, but it'll be basically the same. So this should actually play the sound. I want to show you that this works first. Then I'm going to show you the more complicated setup. Let's go in and test it, hit play. It's pretty brief and quick, which is fine, but it works. Now, what I want to show you is you may not want your designer to go through and find your sound effects and go in and choose a different one, or your sound designer, whoever is doing this. You want to make this a variable that they can very quickly look on the left without having to go through your code and find the sound effect that plays and then change it. So we're going to make this a variable. So right click on this sound node on your play sound at location and select promote to variable. This is a very quick and easy way of turning an input on a node into a variable without having to like make it and name it and all that other stuff. We are still going to rename it to something a little bit better. So let's go over here with our new variable, hit F2 and call it boost sound. All right, we're going to leave everything else the same, but I am going to compile and save and just double check that our default sound is the boost pad sound that we selected earlier. It usually tries to bring that over, but it's always good to check. Now, this is pretty good, but there's one more thing I want to point out. If we were to leave this null, right? If we were to select no sound, you don't have to do this part, but if we were to select no sound and we try to play it, we may get an error. We can't play a sound that doesn't exist. So let's actually enforce. So I'm going to go back and pull my boost pad sound back in. I did Control Z, but you could select it again if you want. Make sure that you have this here. I want to show you a trick. Now, normally in programming, we would do a validation check, meaning we would check if this is not empty or is not null and then do thing. There is a very clean way of doing that inside of Blueprints, and I want to show you. If I were to select this node, this boost sound node, and right click, there is an option for convert to a validated get. So click that. What this means is that it will check and make sure that this is not null. If it is valid, so plug that in and actually connect this other node over here. If it is valid, then play the sound. If it's not valid, then don't play the sound. So basically, if the designer decides not to put a sound on something, then we're not getting an error, it's just not running. And if they do put a sound, then we are running it. So it's a very clean way of doing a validation check, but that's what it looks like. And again, it's a little bit weird, but this is a safer way to code, is to always check before you use a variable that could be empty. All right, let's compile and save, and let's double check to make sure that it still works. Hit play. All right, so it is working. You may decide that you want to change some of the sound volume levels, or maybe you want to get a different sound effect for this. For example, I'm going to come over here and I am going to turn down my music just a little bit more on my, where is it? The funk music right over here. Let's actually rename this. I'm going to hit F2 and call this music player. So the one that's in my level on my outliner that I have over here, I hit F to frame it. I'm gonna scroll down where it says 0.5. Let's actually put this at 0.3. I think that's gonna be a little bit nicer so that we can hear our sound effects more clearly. And you can also go back and replace your boost sounds. You can re-import a different sound, whatever you need to do. But once you get something that you like and you hit play and you hit it and it sounds great, then you are good to continue. Now we're going to do the exact same thing, but with the collectible sound. I did want to show you that I replaced my boost pad sound. I wanted it to ring out a little bit longer. So it's a little bit different if you hear that. That's because I changed it in between videos. But just to show you, if you were to make a new sound and just give it the exact same name that you have over here and then re-import it, it'll just automatically replace it. If you want to replace it, you can. That's how I did it, but you don't really have to. Just use whatever you have right now. For our collectible sound, we're going to do the same thing. The only difference is we're going to link to the meta sound instead of the collectible sound. So let's go to our blueprint collectible, open that up. And there is one other tricky thing here that I want to show you. So go to where you are collecting right here, and let's move this aside because we actually need this to happen before we destroy. So we want to play our sounds right here and then destroy the actor. So I'm going to hold Alt and disconnect. Okay, so after we set our collectible count, let's play our collectible sound, our pickup sound. So pull off of set, type play sound at location, same thing that we did before. This process is the same. We're going to select a sound, and this one is our meta sound, right? Because we had the variation in it. So our ms underscore collectible sound, and our location is the same thing. We want to play it at the location of the collectible. So get actor location. This is the collectible, so we want to get this collectible's location, and that's where we want to play the sound. So connect that, compile, and save. I'm going to do the same thing I did before where I make this a variable. I think it's just good practice and polite to our designer. So let's right click this sound right here that we selected and promote the variable. Pull that over there. We are also going to rename this. So rename this to collect sound. Keep everything the same, compile, save, and over here, just double check that it's the proper default value. It is, okay. And then lastly, we are going to convert this to a validated get. So right click our collect sound and convert to validated get. So this will do our null checking, and this is exactly what we want. So plug our set into our set and our is valid into our play sound. Now this is what I wanted to show you. Currently what's happening, if I plug my play sound at location into my destroy actor, if we do have a sound set and it is valid, we will play the sound and then we will destroy the actor. It is very possible that the designer may not want a sound to play, and so we would plug off this node. But right now, we would end up here and we would never destroy the actor. So we actually don't want that. We want to intentionally allow the designer to not play anything, but it should still continue. It just shouldn't play the sound. So I want to show you, if you set it up this way, you want to make sure that your is not valid continues down the chain. It just skips this play sound at location part. So we're going to pull off of is not valid, skip past, and put it into whatever the next node is. Just make sure you do that. It'll prevent you from encountering some hard to solve bugs if you leave some things as null. Anyways, just make sure you connect is valid to the play sound and is not valid to whatever is after it. This is going to come up in other places too. So this is just the practices. If we do not have a valid sound, just don't play the sound, but continue after. All right, that's enough of that. Let's compile, save, and test it out. All right, we're gonna hit both. All right, it's pretty quick. It could use a little bit more polish, but it is totally fine for now. I think for a prototype placeholder sound effect, it is fine, and the sound designer has a general idea of the kind of thing that we want. All right, in between videos, I decided I wanted a better collectible sound as well. Right, so pretty standard. But the same thing, just make sure you name it the same, and if you re-import it, it will replace it. So do that if you want, otherwise just keep going. Last thing we need is the win sound. I think that's fine. This one, the exact same implementation, the only difference is we're gonna play it 2D. So let me show you. Go to your blueprints and your win volume, open that up. You're gonna find where you are winning, which is right here. We should have already made this, and at the very end, after we set all of our logic, we'll pull off of this, and we're going to say play sound 2D. Since winning is a little bit more general, it's more of a concept than a thing in the world, I think it makes sense to play it 2D so we can hear it everywhere the exact same. So play sound 2D, do the drop down and select, type in win sound, okay, whatever you named it. And for this one, we don't really have to specify a location since 2D means everywhere, so that's kind of nice. And we're going to right click and promote the variable, just like we've been doing, and give it a better name. So win sound, going to compile, save, check to make sure that our default value is correct. We are going to then pull this out a little bit, and then same thing, right click, convert to validated get. All right, so this will make sure that we actually put something in there and hopefully prevent a few bugs. Let's plug in our set into our get and our is valid into our play sound, compile, save, and let's test it out. This will be all of our sounds together in our map. All right, sounding pretty good, and I think we are done with our audio for now, and we can always get better sound effects later if we want. But that's how you replace them, and that's how you implement it. Next, let's talk a little bit about effects, and in particular, I want a burst particle whenever I hit these collectibles. We hear the sound effect and they disappear, but I really want it to explode. I want to feel like I ran into it, it burst, and I then got something out of it. So it'll just feel a little bit better, especially in combination with our sound. So I'm going to show you how to do a very simple particle burst using the Niagara system. Their Niagara system is their newer particle system. If you look under starter content, for me right now, they have their older particles. So this is the Cascade system. We're not going to use these. We're going to learn the newer version. You probably could use this and it'll be fine, but I don't know how long that'll exist. So we're just going to create our own. I'm going to show you how to make a generic particle burst. So go to my _game folder, right click, let's make a new one for particles. And inside of here, I want to make a new Niagara system for a collectible burst. To do that, you would right click, find Niagara system. It might be buried under a menu down here, effects or something, but for me, it just pops up at the top. Click that, and I never know if this menu is going to change in the future, but what I'm looking for is an omnidirectional burst. So if you scroll down a little bit, omnidirectional burst. A lot of these would still be fine. A particle effect is a particle effect, but this one will be more specific to bursting outwards. So I'm going to select this and I'm going to hit create. Now that's going to use that as a template and give me some starting point, which then I can customize. So let's name this. The naming convention, I believe, for a Niagara system is FXS for system _ call this collectible burst. Control S to save this asset. And if you open it up, you'll see something over here. Right, so that's what it looks like by default. And honestly, that's not bad. I'm going to show you how to customize this some, but even if you just play the default, that is something, and that'll feel a lot better than nothing. So let me show you how we can customize this just a little bit. If you click on this emitter over here, this orangish node, you're going to see a whole lot of options and settings and attributes. You could tweak this near infinitely. There's so many ways to customize Niagara systems. You can find a lot of tutorials in making very fancy stuff. We're going to tweak things like color and speed and things like that. So we're going to keep it real simple, and that's all we need for now, but just know that this is a gigantic system that is very powerful. So let's say that we want to change the color. You can select this whole system and scroll down, or you can select the smaller part of it. I'm going to go to particle spawn. So this is all the starting points of our particles, so like size and color and lifetime and stuff. But you could also click the larger node and just scroll down and find it. Either way, I'm going to click particle spawn. I'm going to scroll down until I see, well, I guess scroll up until I see color. Now I could just change the color, like I could change it to orange and that would be fine. But another thing you can do is you can actually change the type of color values. So instead of a direct set, we could do a random range, which the reason why this is cool is because we get some randomization on the particles. So let's say color 1, or minimum, is orange, and the other one, it could be white, right? You could like that, or we could make it maybe like a yellow. We could kind of tweak this a little bit. It'll give it a little bit of variation, and I think that's pretty good. The other thing we might want to change is our size. So right now it is doing a random size with a minimum of 3 and a max of 7. I'm going to make the minimum smaller, so 1, and make the maximum bigger, so 10. You could make this even more if you like, but I think that's fine. I'm going to save it. I think I also want these particles to shoot out faster. Like I want it to feel like I really exploded it. And if I scroll down, velocity speed. So right now it's a minimum of 75 and a max of 400. Let's go minimum of 5 and maximum of 700. All right, so you see that they fly out even further. And I like that effect more, especially if we're moving fast in a vehicle. So that's everything under particle spawn. If I want the other ones, I think I want to change the gravity. So that's going to be further down here. Let's click on particle update. So particle update is things that will constantly happen over time. So a change in movement over time, or like a gravity or a slowdown, things like that. If I scroll up to the top under particle update, you see gravity. Instead of normal gravity, negative 980, I'm going to change that to slightly less, so negative 400. Not super accurate, but I care more about the visual than I care about the accuracy. And honestly, I think this is all I need. I think this looks pretty good for a generic burst particle. So let's save that, minimize. And now we have our particle, we just need to play it. This is the point where you're going to see the tedious patterns. Playing our particles is pretty much the same as playing our audio. We just need to spawn it in the world. So if you go to blueprints, and let's start off with our collectible, BP_collectible. Right after we play the sound right here, so again, we're going to pull off of destroy actor. we are going to play our sound, pull off, and this is called spawn system, and you'll see it appear under Niagara. At location or at location with parameters or some other stuff, we want at location. So this top one. And this is going to get a little bit confusing. So I'm not going to disconnect anything yet. We'll hook all this up once we're done. So let's choose our system template. This is going to be the one that I just created. So our FXS collectible burst. Now rotation and scale and all this other stuff we're not going to change, but we do want to give it a location. So you can just take the same get actor location and plug it in, or you can get a new one and it'd be the same. Maybe this is slightly cleaner. The other thing I'm going to do, as usual, I'm going to turn my system template, right click, promote to variable. Okay, so we have that. Let's give it a better name. Collect particles. Perfect. Let's compile and save. Make sure that our default value is down here. And then again, I'm going to right click my collect particles and do a convert to validated get. All right, so let's give ourselves some more room. All right, this is getting kind of messy. So let's actually hook this up properly now. We want our play sound at location into our get, and then is valid into our spawn system. Okay. For our play sound at location, when we had our is not valid, we were hooking into the destroy actor. We want to pull this one into our get instead, because this is the next node. All right. So we just had to pull all those things off of destroy actor and over here. And in the same way, we get our spawn system. We is valid is in our spawn system, and is not is skip it and go to the next node. So I know it's a little bit confusing, but this is just like an extra little check to avoid an error. So might save you a headache later. I think we have everything we need. So let's compile, let's save, and let's test it out. So we should see a burst at the location of the actor when we collect it. All right, we're going pretty fast, so it was kind of hard to see, but I'm sure you saw the burst fly out when you hit the collectible. As long as it is visible, then we're fine. You can always tweak that later, but for now, our collectible burst is functional. You know, I was thinking about it, and I do want to show you how you can tweak this particle a little bit, because there are a couple things I'm not super happy about, but let's move two of these. I'm holding Alt and dragging out. And actually, let's take this boost pad and put it after the collectibles. That way we can see it a little bit better. So hit play. So that little effect that you saw right there, I think I want to burst them out even faster, and let's over exaggerate our particles. We would rather it be too intense than too subtle, I think, in this style game. So a couple things, let's go back to our particles. And honestly, once you see it in game, that's when you should be doing your tweaking, because you need to see it in context of everything else. So I think this is good practice anyways. Let's take our particle. I do think I want these particles to be a little bit bigger in the game. They seemed kind of small to me. So let's go back to our particle spawn and find our sprite attributes uniform. Let's crank this up to 20 as a max. It's going to look bigger in our preview, but our car is pretty big, so in game, it's going to feel appropriate. I also remembered I wanted the particles to move faster, so that's our velocity. So scroll down, add velocity. I'm just going to crank this all the way up. So instead of 700 max, I'm going to say 3000 max. All right, look at that. Okay, they're really bursting outwards. I think once we burst it outwards, it feels like too few particles now. I think I want to spawn more. Let's select the whole node, and I think it's towards the top over here. Spawn burst instantaneous. So instead of 100, let's change that to 150. You could go even more, maybe 200. I think that's pretty good. Save, and let's scroll down. Actually, let's go to particle update. Last thing is I want it to have a more slow out. I want to burst out really quickly and then slow really quickly. So we're going to increase the drag to get that effect. So particle update, you can go down to drag, or you can click it right there. And instead of 0.75, I'm really going to crank that up. Let's say 6. All right, you see that effect? They kind of burst outwards and hang. I like that effect. So again, you can tweak this if you like. It doesn't have to perfectly match mine. Do the kinds of effects that you like, but this is what I ended up with. All right, now let's see this one in game. So make sure you save and then go back and always test it before you call it done. I think I like that a lot more. All right, now we want a particle burst for the boost pad, and we're gonna do the exact same thing. Again, a VFX artist can come back and make fancier particles. We just need representation. We need something there that then they can replace later. So I'm going to right click in my particles folder again and go to FX, Niagara System, or you can click the one at the top over there. And again, I'm going to do an omniburst. You can do other types of things here, but I'm not going to get too fancy. You can experiment with this on your own time. Omnidirectional burst, create fxs underscore boost burst. Kind of hard to say. So Control S, save that. And honestly, I think I'm going to leave this one at default just so you can see. We're going to play it in game and see what it looks like and then adjust. So keep it at default. Let's try to implement it and go to blueprints, BP underscore boost pad, open that up. And right after we are playing our play sound, let's pull off of that and we'll do our particle burst. So pull off the play sound at location and spawn system at location, and then choose the burst we want. We want the boost burst. And then we also want to give it a location. Now I want to show you something. If I wanted to play it at the location of the pad, it would be right here. But if we hit the very edge of it, we still want to see that burst at the place that we hit it. So I think it makes the most sense to spawn the system at the location of the car rather than the boost pad, which will be way over here. Let me show you how you can spawn it at the location of the car. We know that we can get the location of the player pawn with get player pawn. And then because a player pawn is also an actor, all actors have a location. So if I pull off of return and we type get actor location, this is the actor that we're getting the location from, get player pawn. If we didn't plug anything into here, it would get it from the boost pad. That's called self. But since we did plug our player pawn into the target, we get the actor location of the player pawn. So this will play from the car. This will be a little bit nicer and cleaner. We'll plug that into location. Keep that down there and keep everything else the same. And as usual, I'm going to right click, promote to variable. We'll call this boost particles, compile and save, make sure that our default is fine. I'm also going to do a validated get. So convert to validated get. I'm going to move this over. And I want to show you one other thing. If I move this get, this validated get up and I connect it, and then I connect my is valid, we have our play sound and we have our previous validated get. I could just plug this back in, but what I like to do is I like to leave a reroute node just so I can see that I'm skipping a particular node. So what I mean is I'm going to plug this is not valid from before our sound into our next one for our spawn system. But I'm going to double click on this line. It's kind of hard to do, but you got to like hover over it and it'll highlight. Double click and you'll get a little node here. This is called a reroute node. I'm going to pull it down right here. So this way we can very visually see that we are skipping this node from is not valid. And it's just a little cleaner and lets us clean up our lines a little bit. If I had anything after spawn system location over here, I would do it over here too. So maybe we'll do that later. For now, all we need to do is make sure that we are continuing from our previous is not valid into here. We are spawning the system at the player's location and we are validating. So I think we're good to go. Compile and save. And let's test it in the game. It's probably going to look very generic. Go. I feel like we barely saw it. We kind of made that boost pad way too powerful. Let's try it again. We're going to go real slow. All right, let's see what it looks like. Okay, I saw it. But I do think I want to make that a lot bigger and move faster, so we'll customize that now. At this point, I realized that there were one or two things that were bothering me about my boost pad, and I just wanted to make a intermediary video to fix it. First thing is I wanted to turn down my boost strength a whole lot. I had it at 300,000. I put it down to 100,000 just because I wanted to be able to see the particles, but it just felt too fast. So I turned down mine to 100,000 and that felt good to me, but whatever yours is on, you know, just kind of feel it out and do what you like. So that's under boost strength inside of our boost pad. The handy part about making variables like this is we can very quickly find things and adjust. The other thing is, if I were to have multiple boost pads one after the other, it wouldn't really feel good if I'm going my max speed and I hit a boost pad. I want to feel like I hit the boost pad, even if it's not really boosting me because I'm already at max speed. So if I hit all these together, and actually I'm going to turn down the audio for recording purposes. I'll turn it down low enough that you can hear it, but I don't want it to override me. So let's go to our music up here. Find our music player. So I had it at 0.3. I'm going to turn that even further down. So 0.1. All right. So you can keep yours louder if you want. I just didn't want to override my voice. So what I really want to show you is if I hit 3 boost pads in a row, right? I hit that first one and I'm getting my boost, and I hit the other ones. I still want to feel like I hit the other ones, whether or not it's actually boosting me. And that's just part of game feel. Like, let's play the effects even if we don't actually boost. And that's going to be my solution to it. There are other ways to like clamp max speed and reset max speed and all that. It's too complicated for now, so I'm going to show you the easy way to do it. Inside of my boost pad, whenever we check to see if we're at the max speed and we boost, if we are at the max speed, instead of just pulling off a false and not boosting at all, I'm going to pull off a false and then continue. And I'm going to play all the effects and things after. So I'm going to plug this false node from my check max speed check. I'm going to skip my add force and go into the get and play the sound and particle after. And I'm going to also double click to add a reroute node right there, so I can show that I'm actually skipping this right there. Okay, so I think this is going to feel a little bit better. I should feel like I'm hitting 3 boost pads, whether or not they're all 3 actually doing something for me. So let's go back in, hit play. Right, and then when we have other effects, it'll feel even better. I think that solves some of the issues that I was having with the boost pad, and I wanted to make sure that I showed you all that too. Now, let's make our particles a lot nicer. So we have our generic burst over there, but now that we see it in game, we can customize it quite a bit more. So let's open up our particle effects. That's in our particles folder over here under FXS boost burst. Open that up, and we're going to do a lot of similar things as our collectible burst. So we go to my omnidirectional, and let's see. I do think I want a lot more. So instead of 100, let's do 200. For my color, which is usually the next thing I want to set, let's do another random, so random range. And we're going to make this one purple, kind of like purple and pink, right? So make a maroon. As long as it matches your boost pad so that the player knows what it's coming from, I think that's all that really matters. All right, we have that. Let's make the particles bigger. So that's going to be our sprite size. Let's go 1 and 15. Minimum of 1 and maximum of 15. Again, you can, continue to tweak that if you like. What else? We have velocity. Let's make this a lot faster. Just like before, I'm going to do something like 75 and 3000. Okay, so it should burst outwards a whole lot. Probably something with the gravity. Let's go down a little bit. Gravity. I'm going to put the gravity at 0, so just no downward force. It's just going to burst outwards. And the drag, what do I want to put that to? Something bigger, 5. It'll kind of float outwards. So it should feel like it's moving fast. Actually, you know what? I'm going to make that move a little bit towards the end. So 3. I think 3 is good. Save. Now let's try it. And again, this is going to spawn at the location of the car, not the boost pad. So it should feel a little bit nicer. So hit play. All right, so you can kind of see it in the back. Let's hit it from the other way too. So again, a particle effects person can come in, make that a lot nicer, but it is triggering in gameplay so we know it's there. They will see that and say, oh, I need to replace that. That looks very template. Sure, that's what it's there for. So then they can go in and they can customize the asset, but it is already hooked up in code and ready to go. All right, the last burst effect we need is our wind particles, and let's create that now. So in the particles folder, right click, Niagara system. This one, let's do something a little bit different. I see something called confetti burst, so I'm gonna try that one. If you don't see confetti burst for whatever reason, you could just do another omni burst and that would also be fine. I'm gonna do confetti burst, hit create, call this FXS underscore win volume, Control S to save it, and then open it up. The first thing you're going to see is it's very, very subtle. You might not even see it in the recording. It's like very tiny. So let's make all of our particles bigger. I know that my car is bigger, so I'm probably going to have to make all these particles bigger. So let's go to our sprite attribute under particle spawn, low of 1.5. Let's make this a lot bigger. So let's say 15 and 40 under our sprite attribute. Okay, that's a lot bigger. I like that more. That's a little bit silly. Let's create the sphere radius. Let's make it spawn out from a larger radius. So I'm going to scroll down to shape, sphere radius. Let's make this 100. Be a little bit of a difference. I need these to shoot out more, like they're kind of drifting, and I want it to like burst out of the back of the car when they cross the finish line. So let's do, this would be velocity. So let's scroll down. Add velocity 150 and 800. No, let's do 6,000. All right, there we go. So they burst outwards. I'm kind of zooming out right here. They burst outwards and then they float. Okay, Cool. So it's like we cross the finish line and we shoot out the confetti because we won. Everything feels great. Minimize. And now all we have to do is play it when we win. So let's do that. Let's go to our blueprint, win volume. Let's find the place to play this. I can play it after my sound. So let's pull off of my play sound and call this spawn system, just like usual, at location. All right, and we want to play this at the, we could do this at the actor's location or the car's location. I think I do want to do this at the car's location, but either one would be fine. I think you could make an argument either way. Get player pawn, pull off of the return value of that and say get actor location. So we're getting the car's location and we're plugging the result of that into location. All right. And then what else? We need to choose a system to play. So under system template, let's choose FXS win volume. That's really hard to say. Let's right click, promote to variable. As usual, we'll rename this win particles. And we are going to right click, turn that into a validated get. Again, this will just do our null checks and make this a little nicer. Pull off of play sound 2D, hook it in, pull off of is valid, hook it in. Remember, for the validated get before play sound 2D, we still need to pull off of is not valid. We didn't before because it was the last node, but now we're going to pull off of is not valid and plug it into the next one. Double click our line to get the reroute node. Not required, just looks a little bit nicer for here. I think that's it. Let's kind of pull this up a little bit and let's compile and save. Let's test it. All right. By the way, I did turn down the music on the music player, but you should keep yours at an appropriate volume. 0.3 was pretty good, but I want y'all to be able to hear me in a recording. So play. Okay, pretty good. All right, we're going so fast we could barely see the confetti. Let's remove one of our burst pads right there. Okay, and let's move this other one back a little bit. Spread them out. All right, let's try it now. All right, pretty good. Again, not perfect, but it's good enough to get the point across, and I think it works for now. All right, so we have our audio, we have our burst effects, but another thing we need to do is communicate to the player that these things are collectibles, or they should be touched. Now, what's common to do inside of games is to spin them around, like during the game, so they should be rotating, like a rotating coin or something, and that communicates to the player that something moving is important, and they'll try and pick it up or collect it. Right now, it feels very static, like just kind of floating there, and there's not really any movement in my world. And so what I want to do is rotate these collectibles. Now, we can do this very simply with a component that we put on an actor that will just rotate it automatically. We don't have to put in the code for that. So let me show you. It's very simple and quick, and it will add a whole lot to your level. Open up your blueprint collectible. Over here in components, we're going to add, this is called a rotating movement component. So this component will rotate this actor along a axis or multiple axes and by a certain amount. You can leave it at default, but I actually like to spin it along the Z at 200 instead of the default. It'll just rotate a little bit faster. Compile and save, and just watch what effect this has. If I hit play. All right, so now I want to pick those up, right? All right, so that little bit of movement will help a whole lot. And this is related to something called affordance, which means that we are communicating to the player how this object should be used. Because we are rotating it and moving it, they understand that visual language as I need to interact with that thing. Very common in games, and this is a very simple way in which you can do that. All right, the next thing that kind of bothers me a little bit is when I hit the play button, it just instantly loads in, right? That is not common in games. A lot of times we'll have some kind of screen fade or transition from one part of the level to the next. And fading our camera is a very simple and effective way of bridging the transitions between parts of our level. So our approach for this is we want to fade the camera as soon as we hit the play button from black to in-game. It's kind of like the feeling of opening your eyes in the morning. And when we cross the win volume, we want to fade the camera out after 2 seconds have passed, because we still want to slow down the car, let the player know the time and all that. And then after a brief amount of time, we want to fade out. So let me show you how you can do that. The first thing that's going to happen is our vehicle player controller is going to load in. And once it sets everything up, we are going to fade in the camera. So what you need to do is find the begin play node, like wherever that is inside of your vehicle player controller. Go to the very end. There's a lot of stuff that happens. We even do even more over here. And then the last thing is we want to start fading the camera in. So I'm going to pull off of this node and type start camera fade. And you're not going to see anything here. And I'm doing this on purpose to show you. The problem is this start camera fade and controlling the functionality of the camera, we don't really get access to that by itself. Like we have to find out where that exists. And to do that, it is in a variable somewhere on the vehicle player controller, which is part of the player controller class. And you're not going to see it over here, but if you right click and you say get player camera manager, this get player camera manager, there's two different functions here. We can grab the player camera manager from any class we want. Anywhere in Blueprints, we can get access to it. But because we're in the player controller, we actually have this stored locally already. So either one of these would work. It's just this one is a little bit more proper just because we're in the player controller already. But if we were in the win volume, which we will be in a second, we would want to get the one that just finds it anywhere in the scene. So I'm going to select this get player camera manager under player controller, but either one would really be fine. This one's just more proper right now. So you have to pull off of the player camera manager. This manages the cameras and all its functionality. If you want to type start camera fade. All right, now we see it. Now what we can do here is I'm going to plug in my execution node so that we're actually running it. And then we can fade from a value add a color to another value add a color. Now, if you hover over, it'll tell you what this is. So alpha at which to begin to fade. 0 is fully transparent. That's what we're working towards. And 1 is fully opaque, solid. That's where we want to start. So we're going to change this to 1. It's going to fade from black to 0 is transparent, which is what we want. Then we can decide how long we want this fade to occur over. I think 3 seconds is pretty good. And should fade audio. I think it would be nice to fade out the music and fade in the music. So let's do that and hold when finished. We do want to do this because we want to hold the 2. So this fully transparent. We want it to stay transparent. All right, hopefully that makes sense. You may need to look at this and hover over for extra information if you're not fully understanding it, but this will fade from black to transparent over 3 seconds, fade the audio and hold the transparency once we're done. Compile, save, and let's test it out. Hit play. All right, that is feeling a lot better. It's kind of like, again, opening your eyes, like squinting your eyes open. You're very sleepy. We're all a little bit sleepy. And then we see our fade happening and we're good. So this is how we can fade in the camera when we start the game. Next, we want to, you guessed it, fade out the camera. So what we need to do is find the moment in which we win, and then we want to start a fade out, but we want to do that briefly after a couple seconds. The progression is going to be cross the finish line, lock all input, display some stuff, wait a couple seconds, then start the camera fade, which will then fade over another couple seconds. So open up your BP_win volume. I already had mine open, but you can also find it in Blueprints wherever you are saving it, BP_win volume, and find out where you are winning. This is a very long chain of stuff. So I'm actually gonna do one thing here. I'm going to select all my audio and particle stuff, hit C to comment, and just say effects like that. So we can kind of compartmentalize this a little bit more. Off of my spawn system at location, I can't really get my camera fade unless I have the camera manager, right? Back on my vehicle player controller, we need to get the player camera manager. So this time we are not on the player controller, which means that if we right click and we say get camera manager, we only have one option here, is the game get player camera manager, and that's fine. That'll just get us the active camera manager, which is exactly what we need. Pull off of that and type start camera fade. All right, so start the camera fade on the active player camera manager. So we actually want to start from transparent and fade to opaque. So our to alpha will be 1. So from alpha 0 to alpha 1, duration, let's say 3 seconds, color black, should fade audio. Let's say yes, let's fade audio, but I could imagine if you want to play some victory music or something, you may not want to, but I'll fade audio for now. Hold when finished, yes, let's keep it black. We are going to connect. Well, actually, let's think about this. When we spawn our particles and we win and all that, we don't want to immediately start the camera fade. We want to wait a certain amount of time. We can do that with something called a delay node. So I'm going to pull off of spawn system at location and type in delay. You can see a couple options here. I want this top one, just delay. And we want to choose how long to wait. And let's say wait 2 seconds. And this will literally pause the progression of our logic right here. We'll just stay in this node for 2 seconds, and then it will continue out of the completed. So one other thing here, our previous node was a validated one. We want to make sure that if we didn't assign a particle burst, we still continue. So let's skip into the delay. Let's add a reroute there. So double click, drag it underneath. Okay. So delay, after we do all the other stuff, we're going to delay for 2 seconds. And then once we're complete, then we're going to start our camera fade. I think that's all we need. I'm just kind of cleaning it up a little bit. Let's compile, save. It's a lot of little random stuff and numbers to change, but really quick effects. Let's hit play. All right, feeling pretty good. And it fades out. I like that. Now you'll notice that it's not fading the UI as well. There's other ways to handle that, but I'm not worried about that. I like that it keeps the high score up there, so I'm okay with that. So another effect that we can use as part of our game feel is a screen shake. So what I mean by that is when we hit a boost pad, for example, we want to shake the screen kind of like that. It gives a lot of extra feeling of power and rumbling, and it really makes the player feel like something very impactful just happened. So when I hit a boost pad, I really want to shake the screen very briefly to give an extra sense of weight. So let's talk about how we can do a screen shake. The approach is going to be making a camera shake asset, and then once we customize that asset, we can call that inside of the blueprints, inside of our boost pad, and maybe even our wind volume. So we're going to make our asset, customize it, and then we're going to play it inside of our mechanics. So first things first, let's go and make our asset. I'm actually going to make a new folder over here under _game. Let's right click, new folder, and let's just call this gameplay. And this is where I'm going to put some stuff that might be not super specific to an asset, but just like general game assets that are customizing various things. I'm going to right click and go to blueprint class. Now I want to show you something. This is a little bit weird. Right now we've been making some parent classes from these defaults up here, but we actually have access to a whole lot more. If you expand this, there are so many classes that you have access to inside of Unreal. And these are just like the parents. There are other ones underneath these drop downs, or you can make your own. But what I want to do is look for something called camera shake. I look down here, shake base. So this is the simplest, most basic form of a camera shake. Hit select. And once I create this, I can call this BP_generic camera shake. So we've created our camera shake asset that has all the information on how to shake the camera. If you open this up, now we need to customize it. So let's talk about a few ways that we can customize this. The first thing is single instance. This means that if I have multiple camera shakes back to back, like that are overlapping, it will further increase the camera and it'll get out of control. Single instance just means I want to reset this one. I don't want to like extra camera shake. If I hit 2 boost pads, I just want our default one. So we'll click that. There are also a couple different options you have for shaking the camera. I'm going to keep it pretty simple and just do Perlin noise. It's a very simple pattern. And main things to watch out for here is our timing and our location. You can also tweak with other things here, but our location, our amplitude is going to be how big is our camera shake? Like how much are we moving the camera? And our frequency is going to be how fast are we moving our camera. So between these certain points, how quickly are we shaking versus how big are we shaking, if that makes sense. I've kind of experimented with some of these numbers. As a starting point, I'm going to recommend 35 for my location amplitude. So this is, the amplitude is how big, so 35. And my frequency, I'm going to recommend 15 as a starting point. And then you can experiment with these values if you want something that feels even bigger or even faster, if you like. The other thing is my duration. 1 is an okay default, but I actually want my duration to be pretty brief. So I'm going to say 0.75 just to be a little less than a second. Our blend in time is how quickly do we want to start shaking. I'm actually going to put this at 0 because I want it to be instant. The moment I hit that boost pad or start a camera shake, I want it to start going off. I really want it to start shaking immediately, but I do want it to fade out. So my blend out time, I'm going to say 0.5. So no blend in, a decent amount of blend out, and only lasts for 0.75 seconds. You can definitely mess with all this, do your own game feel and make it feel how you want, but this is a good starting point for me. So let's compile and save. And that is our camera shake asset. So we have our camera shake asset, but now we need to use this asset and play it inside of our blueprints at the correct moment. So we want our boost pad. The moment we boost, we want to trigger a camera shake. And when we win in the win volume, let's do it there too. So let's open up our boost pad first, and we're boosting. We are playing all the effects, and let's do the camera shake right after we do everything else. So in order to play our camera shake, we actually have to play it on the player controller. So if I right click, let's get player controller. And you're not really going to know all this just by default unless you've been doing some blueprints. So don't worry that you don't know where all this stuff exists. That's part of why I'm showing you. So like the common things you'll want to do. Eventually you'll start to remember what player controller can do, what camera manager can do, what this node is called. And honestly, that's the hardest part about node-based scripting. For now, I'll just tell you the most common ones and where they exist. So inside of get player controller, we're going to pull off of our return value, and we're looking for something called start camera shake. So you're going to see client start camera shake. It has a kind of a funky name, but this is what we're looking for. From source would be like if impulse point is shaking near you, it'll calculate how much to shake based on how far away you are. But we just want to shake the camera. We're not going to get too fancy with it. So start camera shake, this top one, client start camera shake. All right, so we have our target. We just need to connect the nodes. Let's actually select the shake that we made. We could make different kinds of shakes. We could use existing ones, but we have the one that we customized, BP_generic camera shake. Plug that in. We'll also plug in the execution pin. Also remember, since we did have a validated get here, just to prevent a bug, we're going to connect the is not valid. Again, not required, but in a couple places it might cause an error. So let's just fix it. Player controller, I think this is all we need. So we could control the scale if we want to very quickly pull that up or down, if it's too much or too little, but I think this is a good base for what we need. And I think let's just try it out. Compile, save. Let's see how these boost pads are feeling now. It should be a lot better. Those boost pads feel a lot better, and the camera shake makes them feel like we are really impacting them as soon as we hit. And now we want to add a camera shake to our win volume. So let's open that up and open up your BP_win volume. And before we do our delay, right, when we start waiting for our camera fade, right, we want to do our camera shake immediately and then start our delay for our camera fade. If you were to put this after our camera fade, our camera shake would just appear randomly a couple seconds later. So let's immediately play our camera shake, then we'll start our delay and camera fade. So first, right click and type get player controller and pull off of get player controller, and we want to start camera shake. So this client start camera shake. This top one right here. Pull that in, let's connect it, spawn system at location in, and we're also going to connect our is not valid into this node instead of our delay. So I'm going to pull off the reroute node down here just to show you. That's a quicker way of doing it. And we also need to select the type of shake that we want. So the one that we've been customizing, our BP_generic camera shake. And then the last thing is we need to connect our start camera shake exit node into our delay. All right, so we're just kind of hooking it all in appropriately. And as long as we are doing our camera shake and we are selecting one and continuing, I think we're good to go. Let's try it out. Compile, save, and play. All right, let's go. It was pretty quick, but I think I liked it. I don't really need that to be over the top. I don't think I need it to be distracting, but it was just enough to feel like we did something important. And I think that's the appropriate way to use it. All right, now let's talk about slow motion. A lot of times in games, when you really want to emphasize something important happened, like you just knocked out the other fighter or you just crossed the finish line, it can be a really cool effect to slow down time very briefly and then continue back to normal time. And we want to do that. As soon as our car passes through the win volume, let's slow it down just to make it feel really cool just for a moment and then continue. We're also going to try to do that on our boost pads, and that one's going to be really subtle. Like the moment we hit a boost pad, we're just going to very, very, very briefly slow down time and then continue. And you're going to barely notice it, but you're going to really notice it when it's missing once you're used to it. Our approach for this will be something called global time dilation. When time is moving normally, it is at 1.0, so just 1. If we were to make it half, so 0.5, time will move at half speed. If we were to put it at 2.0 or 2, time would move at double speed. So we can actually control this in Blueprint. And what we're going to do is we're going to change the time. So slow down time, wait a small amount of time, and then speed it back up. So time dilation, a delay node, and then return the time to normal speed. So let's do that in our mechanics. First, we're going to do this inside of the win volume. So if I go over to my win volume over here, BP_win volume, we are shaking the camera, then we are waiting and doing our camera fade. And I'm going to pull that out. Let's slow down time as soon as we do the camera shake, right after, but before we wait and do our camera fade, we're going to slow down time, wait a small amount of time, and then return it. So let's look at what that looks like. So if you go over here, so pull off of client start camera shake or whatever your previous node is and look for set global time dilation down here at the bottom. Set global time dilation. This will make time move at 0 speed. We'll be trapped infinitely. We don't want that. Let's put it at something pretty slow, something like 0.3, I think is a good value as a starting point. Then we're going to wait a small amount of time. So we'll do a delay. So pull off of that and do a delay node. Let's wait for 0.5 seconds. But know that this is kind of weird because we're waiting for 0.5 seconds, but at 0.3 speed. Like time is moving slower. So when we delay for 0.5 seconds, it's actually delaying for 0.5 seconds times 3 almost, right? Like we're moving at a third speed. So this will take 1.5 seconds. It's kind of weird, but you can adjust these numbers if you want it to feel slightly differently. And then the last thing, I'm going to pull off of delay, and then we have to return it to normal speed after the amount of time. So set global time dilation back to 1. And just make sure you check your numbers. If you leave a 0 in there, it's going to freeze and you get confused. So make sure that your numbers are appropriate. Make sure that you return it back to 1. And then we're going to do our 2-second delay for our camera fade. I'm actually going to highlight these 2 nodes, our delay and then our camera fade, and hit C. Just call this camera fade. And I'll do the same thing for our slow time. Let's select our set global time dilation delay, then our second set global, hit C, call this slow motion. Now we can move these out. And let's actually test this out. I think this will work. Hit compile and save. And again, you can tweak these numbers, but let's see what we have. All right, that's feeling a lot better. That brief slow motion for the player to jump up and clap their hands or whatever. It's a super hard race. They got their top score. And it feels a lot better, right? Weightier and more impactful. And that's what we want with our game feel. All right, so the other thing we want is a little bit more subtle. I want to slow time very, very, very briefly at the moment that I hit the launch pad. So when I hit this, see right now it launches me forward right when I hit it. But you would notice this in games that have like a really heavy impact, like a big sword swing or a knockout punch or something. They will slow time at the moment that there's impact and then speed it back up after 0.2 seconds or something. I want to do a very subtle version of that so that when I hit the boost pad, it's going to hold for a brief amount of time and then launch me forward because the game is going to actually slow down. Let's try and implement it and see how it looks after. And then you can always adjust it to make it feel even weightier or even more subtle if you like. So I'm going to open up the boost pad and we're going to find at the moment that we boost, and actually let's just do it right after the camera shake. I think that's fine since that's already working. Pull off and set time dilation. And we're going to set this to something like 0.2. So it'll still move, but very slowly. And then we're going to wait the smallest amount of time. So let's do a delay. And I'm even thinking like 0.03, something like that. 0.03. So it's going to be like 5 times as long as that because of our 0.2 speed, but it'll be very, very brief. And then right after that, we're going to return it to normal. So again, set time dilation back to normal. Okay, let's highlight these 3 nodes, hit C for comment, and call this slow motion, just so we can find it easier. Compile and save. Now this might feel subtle, but you're going to notice it when you play it in your own game. So let's try it. Right? It's that brief hang and then a launch forward. When you stack these little things together and you have the sound and the particles and the slow motion and the screen shake and all this together, it just creates this feeling of power. And that's what we're aiming to get for something like a boost pad. So this is feeling pretty good to me. You can adjust these values to make it more or less subtle if you like, but as long as you have this brief hang in your boost pad. The feeling is there, and this is what we want. All right, so we have a lot of sounds inside of our map, right? If I go around, I hear the music, hit the boost pads. Oh, that sounds pretty good, except the problem is our giant car has no sounds on it. We would expect a big engine that's revving up and moving around. And that feels like it's missing now that I have all these other pieces implemented. So let's implement a looping engine sound. And this might be a little complicated, but I think it's going to really add a lot to our game. So I'll walk you through it the best I can. First thing is making a looping engine audio sound. It's kind of hard to do through a synthesizer. So the instructors will tell you where to find the sound that we're going to use. This is going to be a pre-built asset that we're using. But wherever they direct you, it could be a download link. It could be, you know, some file that exists somewhere. They will let you know where to get it. But once you get it, we're going to import it. So I'm going to go to my audio folder, import, and then find whatever this file or wherever you get this file from. And for me, it's called engine idle _ loop. So import it in. I'm going to save it, Control S, and we can test it to hear it. Okay, it's pretty boring, but it is a looping engine sound. Like maybe yours sounds different if it's updated, whatever. As long as it is a looping engine sound, you are fine. Now we want to play this on the car. If you go to your vehicle template inside of your content browser, we have a couple options here. We can play it from the off-road car, the sports car, or all cars. Now, I don't think I want to implement this sound just on one car. I think I want to do it on any car that we decide to customize. So I'm going to put this on the vehicle advanced pawn, which is our parent car. So anytime we make a new car, it's going to be based off this under vehicle template blueprints and vehicle advanced pawn. You're going to want to open that up. And inside of here, inside of viewport, we're going to add a component. So add, we're looking for audio because we want to play audio on this car pawn. Compile and save. So with audio component selected, we're going to come over to the right and under sound, we're going to type in our engine idle loop that we have. It's going to be pretty loud. I think this should be a little bit more subtle. So I'm going to turn this default volume down to 0.5. Depending on how yours sounds in your game, you might want to adjust that some, but 0.5 worked pretty well for me. I'm going to keep this pitch multiplier at 1 because I'm going to control this in code to make it rev up and down, but I'm going to keep this at its default 1 for now. Compile and save. And there's actually one more thing I forgot to do. If you come back to your audio, when we imported this engine idle loop, I actually forgot to tell it to loop. So open this up, and where it says looping, we want to check that. We do want it to loop. We want it to continue to play over and over and over and over while we're playing the game. All right, so now if I come back and I hit play, our car should have a looping engine idle sound, and it shouldn't sound too loud or too soft. It should sound right in the middle. All right, so we can hear it, right? But the problem is it's not revving up and down while we're playing, and that's what we want to do during the game based on how fast or slow our car is going. All right, so to control the pitch in gameplay is a little bit weird. I will try to explain it the best I can, but even if you don't fully understand it, as long as you follow along, you'll be fine. So let's go to our vehicle template, blueprints, and vehicle advanced pawn. Open this up and go to the event graph. All right, so what we're going to do is in tick, which we need to find over here for me, in tick, we want to constantly check, and we want to check the engine rotation. So basically, how fast is the engine spinning, or how fast are we going? And we're going to check the engine rotation, and based on how fast it is, if it's moving faster, we're going to pitch this engine idle loop up. If we're moving slower, we're going to pitch it down. So the effect should be when we're not moving very fast or idling, it should be a low rumble. And when we are going at max speed, it should pitch up like a high-pitched engine sound. So let's walk through how that would actually look in code. So our event tick, we're doing other stuff that was already written for us, blah, 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 and we're going to pull out the last thing that we see. For me, off of this event tick is going to be interps to original rotation. Whatever your last node after event tick is, just pull off of that. but I'm going to work off this node right here. So the first thing I'm looking for is the engine rotation speed. It's a little tricky to find, but it exists inside something called a wheeled vehicle movement component. Because we're inside the vehicle advanced pawn, we can get access to the wheeled vehicle movement component. So if you right click and type get wheeled right here, get chaos wheeled vehicle movement component. That is such a long name, but if you click this, we can get access to it. And from this, we can get the engine rotation speed. So get engine rotation speed. All right, it's bottom one. So this should tell us how fast the engine is rotating, which is something that we can use to adjust the pitch. All right, so this is where it gets a little bit weird. What I'm trying to do is let's get the audio component and pull that in. So drag and drop it into our blueprint graph over here. If you pull off of the audio component and type set pitch multiplier. So you want this top one, this audio component right here, set pitch multiplier. We can change the pitch of our audio component that our engine idle loop is playing off of. And 1.0 is our default pitch that plays the sound normally. If we go lower, so like 0.1, that's going to pitch it down. If we go 2, that's going to pitch it up. So what we're trying to do, if I pull my previous execution pin off and connect set pitch, just like that, we want to drive the new pitch multiplier every single frame and tick, which is what we're doing right now, right? Every single frame. We are constantly changing the pitch multiplier on our audio component. We want to pitch it low if we have a low engine rotation speed, and we want to pitch it high if we have a high engine rotation speed. So this is weird, but the easiest way to do this is we want to map two values in a range to two different values in a range, meaning we want to map a low engine rotation speed to a high engine rotation speed, like this range of low engine rotation speed to high engine rotation speed. We want to take that full range and map it to the pitch range, which will be 0.1 to 2. So we want to map our low engine range to high engine range to our 0.1 to 2. So remapping these two different ranges, we have a handy node for this. So if you pull off of the result of our engine rotation speed and type map range, you have two options here, unclamped or clamped. I'm going to do clamped, meaning that we can define what the low end and the high end are for each of these, which is just a little bit safer. We want to decide a low from our engine rotation speed, a low and a high. So our low is going to be 0. And I just know from testing our high end for our engine rotation is going to be something like 6,000. Might be a little bit different if you adjusted your car values or changed the max speed. But for me, this was pretty good. You can always tweak this number. And our out is going to be the pitch that we want to set this first range to. So I'm going to map the range from 0 to 6,000 to 0.1 pitch and 2.0. If you go above 2.0, it's usually kind of funky, but this is good enough for now. We can always make this more complicated later. I want to set the result to our new pitch multiplier. So plug that in. So I know this is kind of a funky concept, but this is the easiest way I can explain it. We're mapping this engine rotation speed range to our desired set pitch multiplier range. All right, so let's just try it. And if it works, and we're fine. So we'll pull all this a little bit closer and let's compile and save and let's see how this sounds. Hit play. Okay, so you hear how when we go faster or slower, our pitch on our loop changes. Right? Okay, cool. So it's not perfect, but it's good enough to give us that variation, and it sounds close enough that then our sound designer can be bothered by it and they can go fix it and give us a better engine loop or go through the specifics of how to pitch that. But for now, it's working, and I think that's good enough to communicate an engine idle that is changing based on our speed.